Ladies and gentlemen, boys and girls, Jesse Warden here. Today we're going to talk about how I should code with AI.
Jesse Warden.
Why are we talking about this? Well, there's about 5 reasons. I was told to use AI by my boss early. So some of you might have been put in a position where you've been told to do this, or you were strongly encouraged, or even being tracked by VSCode plugins on how you use AI. So if you're like, I'm forced to do this, what's the best way to do this? Jesse Warden, that's me. You're back. Number 2, jobs are now expecting developers to have prompting experience. I've seen real companies who I've talked to, people who work there, they are actually advertising the requirement to have experience doing prompting, but not just prompting. They've done requirements with these LLMs. They've done all kinds of experience doing vibe coding, to the whole gamut of that. They want to see that you've been using these tools, leveraging these tools, interacting with these tools, and it's not your first time. So that's what they're looking for. And so if you're like, I don't want to go in an interview and have no idea what they're talking about, I can get you the basics. After that, you're going to have to play yours. AI keeps going off the rails. So I'm not going to cover this, but a lot of times people, whether they're doing vibe coding, where they just have the AI do everything and they kind of just accept it, or they tab forever and they just let it fill it out, or they generate a huge list of requirements. They go through the plans and they iterate through these plans in a very waterfall style of development. And the AI just seems to go off the rails, and they try to self-correct it. And they're just very frustrated. They don't understand how the social media experiences they read about don't reflect their own experiences. So the technique that I use kind of controls that explosion, so to speak. Number 4, I have no idea about this LLM coding stuff, and I want an example. Cool. So mine is one example of many. I'm actually going to do coding. I'm not going to have the AI code everything. But there are a lot of examples out there where they do vibe coding. The AI codes everything, and they're just requirements gathering. I'm using it as a tool, and I treat the AI very similar to a junior, and the growth trajectory is unknown. So I treat them just like I would a person I'm working with on my team that wants to learn, and I want to learn from them. So I treat it as a peer. Okay. Number 5, there's actually 3 possible futures. There's a lot of futures, but a lot of people have tried to predict the future. And I'll tell you the ones that I'm basically focusing on, the reason I haven't really changed how I develop much. So the first is that this goes to AGI, but slowly. So AGI means basically generalized intelligence. The model can reason. It becomes like us. It can think, but not only that, it can learn, which they can't really do right now over a long period of time. And it gets to our level of intellect and ability to find problems, interpret requirements, because that's a big thing that we saw for developers try to do, is iterate towards what the requirements actually mean for the product owner, then it'll iterate towards the requirements actually mean for the user. So if it goes slowly, then this technique will eventually find a way to mentor the AI over time, and the AI will eventually become better than us. I have repeated this multiple times in my career. I've been a tech lead for 12 years at this point. And so I've watched a lot of these junior developers come in, and they're now like senior directors, right? I'm old enough to see the continued repeat of a lot of these developers I've worked with. They've gone to be senior directors, they've gone to be senior distinguished engineers, just rocket in their career. Some have titles that don't indicate their actual talent and ability to do things. And so I was glad to be part of that journey. I was glad to be a small part, to see, watch them grow and become just way better than me and successful. And that's amazing. But AI is kind of on the similar trajectory right now, at least if this future holds true. And so I can say, hey, I was there when they were dumber than bricks and they couldn't learn like juniors. And then I saw the slow progression where they were really, really fast, faster than any human, but they didn't have the ability to retain. They had to be controlled. And, eventually we gave them more freedom and they had more autonomy, just like a normal developer. So this technique is wrapped around that possible. Instead of a junior growing up and acting like a parent and a mentor and a coach, and they eventually far exceed becoming awesome. That's what this technique's for. Another feature is that they slightly increase in usefulness. So there's many of us who are cynical and don't find them useful at all. And there's a lot of people who just keep trying, keep waiting. Linux Torvalds is one of the examples where he finds, some of those things amazing and useful, but he's kind of like tapped out because the hype is so hot right now, right? I did the same exact thing when VS Code came out. The first build I got, it was ridiculous. Sublime Text 2 was clearly superior, had more plugins, and just worked. And within about a year, that drastically changed, right? So when I came back into VS Code, everything was ready for it. It was fantastic, and it was very, easy to quickly. And that's another thing, is that we developers are very, very quick to learn. So if AI can help usefulness in both learning and development, then it's worth investing now to be aware of the limitations and know when it is useful, right? To recognize those signs. So these techniques will help. Lastly, LLMs peter out. So the good news is 90% of this will still be useful if LLMs kind of just peter out and nothing happens for a while. Maybe world models come out, maybe different models that are reward-based and are actually more useful. Whatever that is, we're going to use the same techniques on those different models. And so even if they peter out, a lot of these techniques are just normal development anyway. So it's still worth your time just to say, all right, we saw what AI had to offer. We're a little more intelligent about their capabilities and trade-offs and the things they can't do. So when people say things, it's like, look, I've already been there. I've done it multiple times. So those are the 3 possible futures, and these are why we're talking about this. So what we're going to build is a simple AWS Lambda HTTP GET point. I'm just going to do maybe 2 to 4 examples. Really simple stuff, but a lot to explore in there. And we're going to kind of emulate pretending to read from local disk or maybe S3 or maybe local and abstract that. So a lot of it is we're going to explore the code in a certain methodology, but there's a lot of depth there and a lot of architecture we can think about ahead of time. So it's a cool gamut for a very simple. And backend is a lot easier. So that's what we're doing. All right. So how is the big deal? How is probably why you're watching this video? How is what I'm still trying to figure out myself? This is a new space for a lot of people, and a lot of developers have approached this variety of goals. So let's talk about it. We're going to use 3 techniques. We're going to start with type-driven development. Types are a way to narrow your problem space. They're the way, kind of in an algebra way, to say this is a correct way the code is supposed to operate under these conditions. And they work really well with AI because AI is trained on a lot of TypeScript and a lot of type-based languages. For some reason, the pattern matching works really well with languages that support pattern matching. Imagine that. Things like Elm, Python with types, Haskell, OCaml, Scala, languages like that have types. TypeScript has it too. There's a variety of mechanisms that you can do it with, but basically it's either if or switch. Right? That's their version of pattern matching. So those types work really well, and they help us work with the AI. So we'll talk a lot about that in a minute. Our next technique is test-driven development. Test-driven development is a way to design code with tests. It is not a way to write a test first. You might have heard of writing refactor. It's not a way to write a test first and then just do the testing first. It's more of a design technique. And what we're trying to do is use those tests to assert that we understand there's requirements. So this whole presentation assumes you know the requirements. That's why I had on that slide what we're building. It's very clear what we're building. The requirements are very to the point of what we're expecting from this API. However, asserting that in code is where a lot of our jobs as programmers. Some people approach this very differently. Some people do test during or test after. In fact, there's a gamut of developers that seem to approach this in a variety of different ways, where the vibe coders will just go with it. They're interested in the requirements. The test after developers seem to really, really enjoy writing the code, and they have a negative relationship with test. And there's a variety of reasons with that, which we can talk about. The idea is that they don't enjoy that. So they get the AI to automate what they don't enjoy. So the requirements people, they enjoy thinking about the problem space, thinking about the solutions and iterating on that, and using that. AI is either a rubber duck or kind of like a pair programmer, more from a product angle. And so that's what they enjoy. And they let the AI do the actual coding. The other developers really enjoy thinking about the logic and the problem space, the details of the code. That's what they love. And so they have the AI kind of generate all the tests because they don't care. They feel like once they've reached their logic, the code works. That's good enough for them. They've seen it work manually. And the tests are just a way to make sure they don't break anything in the future. That's how they, view that process. Then there are the people that are from the TDD realm and XP realm, extreme programming, like Kent Beck, Martin Fowler, Dave Farley, Paul Hammond. And what they do is they use the test to drive the design, and they keep the AI constrained. So they will focus on the test area. And there's also some variation here, nuance here, which I'll talk about as well. But they believe that normally in red, green, refactor or test-driven development, where you write a test, you see it fail, and then you get it to the green state where you do the minimum to make it pass. The rest of it's spent refactoring, right? Once it's green, you just have fun making the code at first actually work like you expect. And each one of those tests is going to drive that implementation even more. There are some who will write all the tests. So Kent Beck has kind of come back into the community a lot lately. And one of his XP-isms, or extreme programming, because he's the one who invented it back in like 2001, 2003 or 90s, is that he has an idea ahead of time of what the tests he wants to write, the happy path, the unhappy path, the edge case, various other unhappy paths. I've seen some TDDers who write all those tests ahead of time because they enjoy thinking about the design and how those tests will assert that design and validate. Do I like, building the code that I want to use? And so the AI can just implement it. Because the AI has a lot more tests, sometimes it has a lot more context from those tests to go, okay, you want me to make these tests pass, got it. And others, such as myself, think that a single test is really what we should be focused on to understand, do we really take the AI out of it, take the product owner out of it? Do we really understand the requirement? I always go back to Brian Finster's The Three Wrongs. The requirements are wrong. Your understanding of the requirements are wrong. The user's needs will change during the project, right? And after you delivered something. And even just one test can really elucidate or reveal how much misunderstanding you have, how much understanding you want to gain. And it really allows you to play with that and understand that. And so I feel like it's a middle of that where I come from. So I'm gonna tackle it from that angle, but just be aware there's nuance, even in the TDD sphere, which is like what, less than 1% of the software industry. Even within that sphere, some of the thought leaders kind of differ on how they approach it because this is a dynamic space right now. It's changing a lot. So we're gonna do it in a Chicago style. So if you're not familiar, there's kind of two styles of TDD. London is where you say, I want my app to do this. You literally write a test for your app. So that's a Lambda. You would have the handler have a return type, and you would just start implementing everything. And depending on how you approach it, in the old days, it was called the mockist approach because mocks were very popular back then. Nowadays, especially from a functional perspective, it's more of a stubist approach because you're stubbing all your side effects and like that. Or you're leveraging a lot more types. But either way, that is very difficult from an AI perspective because some of the implementation details you're going to discover, and you might do a lot, temptation to do a lot more implementation. And what we're trying to do is the opposite approach. Plus, if you've never done TDD before, test-driven design, difficult for a lot of developers who had a bad taste in their mouth from TDD because they're like, how do I know what to write? I haven't figured out the code yet. And that's actually what TDD does. So if we approach it from a Chicago angle, we're actually approaching the implementation details that lead us up to that. So you still get that feeling and fun and joy of kind of exploring the little minutia, the little pieces that you're going to build, like the little Legos to put everything together. So we're going to do that approach because it's small, it's constrained, and it's a lot easier for the AI to be more successful at that than the AI to go off the rails doing in the London style. So that's just why I'm approaching it. It's easier for the AI. It's easier for people who've never seen TDD before to kind of grasp. Now we're going to do it with Claude AI Assisted Development. So all three things are kind of going in that order. And Claude, we're going to run in a command line next to our test in VSCode. We're not going to use Cursor or Windsurf or anything like that. I want to use VSCode where I'm comfortable and have Claude help me there. The interesting thing is there are two models that Anthropic currently suggests around Sonnet. So it's Claude Sonnet or Claude Opus. And the Sonnet and Opus models, a lot of people on the internet, my social media sphere, have claimed that Opus is just really amazing. But more importantly, when it hallucinates or has a problem, it's a lot less severe and it's a lot more bearable. I've been using Sonnet. I've been pretty impressed with Sonnet compared to something like ChatGPT or ChatGPT 4.0 or 4.10. So that's what we're going to go with. We're going to keep it there. And the idea is that D can be replaced with new models in the future. So if you're someone who really enjoys Gemini, everything about these techniques can be replaced. You just put Gemini in D and you're good. So whatever new model comes about, whatever new way, everything's going to be the same for A, B, and C. It's just D is going to be replaced as the models get better or different. So, for example, if the LLMs eventually peter out and Anthropic can't make him, any better as far as coders are concerned, it might be better in other problem spaces. But in our industry in software development, maybe a world model is better, maybe a reward based, and we're going to replace that and see how that grows. So this is kind of like, think of it like the chassis that you have, and what you put inside of it is the engine. So that model, we have the way we have a car, we drive it, we interact with it, but the engine can change everything. That it's the same style of interaction, it just changes how it powers. We're going to use TypeScript Vitest on Node. So TypeScript is the types language we're going to use. Again, this applies to Elm, OCaml, Scala, Java, C#, any F#, any language that has types is one of the first things you're going to do. So you can do this style of development with like Python without typings, or JavaScript without typings, or Lua without Luau, which is the Roblox types on top of it. So you can approach it with all of them, but we're using TypeScript to get the types specifically. And then Vitest is one of the best bundlers and runners and test engines. And it has a Jest compatible API, but it's not slow and obnoxious like. And then we're going to run on top of Node.js for both our terminal and assumed runtime and compilation. And then VSCode, we're going to have Claude Commandline in it. And again, you can use Cursor, you can use Windsurf and all those others, but the idea is for some people, they'll actually run in their environment and they'll have something like Cursor or something else doing checkups. So they'll have multiple agents check on each other. We're not going to do that, but that is an interesting way to do it, because you can interact with the AIs in Cursor, such as a completely different model like Gemini 2.5, for example, and have it look at your code and see, all right, this is what Claude is suggesting. Is there anything off? So sometimes people will spawn multiple agents, sometimes the same agent, but in this case, it's another interesting way to do it, and you get to play with two tools at once, so you kind of learn a lot. We're going to iterate on the context file. So one of the things that LLMs currently can't do is they're trained on data, and that's what they know, and that's it. There's no way to easily teach them. There's no way for them to learn something new. So some of them have what's called a context window, and we just call it a context. And within that context, they can take in information, but that's not like short-term memory. What short-term memory is more about a session. So over time, it remembers what we've talked about. It remembers what it's done. It remembers what it's changed, what I've changed, and things like that. And so we're going to iterate on this file that's called a context file. And the reason that's important is that when you talk to an AI or a lot of the LLMs, you've got to be very explicit and terse and to the point. So it's good practice for developers who have communication challenges, but it's also good because it narrows what the model delivers, and it's very easy for it to deliver the code you want if you're very clear on those communications. The context file is great because that way you can write all your requirements and expectations and way you do things in a file. And then every time you talk to the AI chat model or LLM, it'll read from that. So you don't have to specify that every time you talk. Or if the session ends, you don't have to specify it again. You just make sure it's reading from that file, and the expectations of how we work together set. A lot of times with juniors, if we're doing like pair programming or mob programming or swarming, for example, people have to learn from it. They have to learn how that person operates. So for example, I'm working with a lot of people from a Java and C# background. And so a lot of the functional programming techniques that I talk about, I have to explain, and because I know where they're coming from. I understand, so I can relate it to their type system, their design patterns, the statefulness of classes versus the statelessness of function. It's a lot easier for me to communicate effectively to them because I know where they're coming from a background. The AI can do the same thing with us because you give it that context file and this is what I'm about. This is how I do. What do you think? And AI is like, cool, I'll work like that. And so that context file, you start, but you learn that sometimes the expectations weren't set right, or you didn't give the AI enough examples, or documentation is missing from a library. So we're going to iterate on that context file. We're also going to review, validate, and refactor code. So the whole concept of this is that we're building things in small iterations or small batches. We're going to review it, see what it did, and talk about it, and see what the LM did and compare that to how humans do, and also compare it to past models. So I've experimented with GPT when it was from a command line perspective, and then it was really just tab completion. So they had a command line, but really from a code perspective, you would hit tab or start typing and it would code complete. And instead of like looking at your project section and say, here's what's available, it would suggest things for you. So you could literally just tab and it would code everything for you, right? It'd say, do you want this tab? It would auto write it for you. Eventually they got the chat feature, but even then, a lot of that stuff was too aggressive, too far out. And Claude and Sonnet are so a lot better at the older models, you're more likely to accept that. The temptation is there to say, wow, I can see why the vibe coders want to do this, but we're going to resist that temptation and we're going to work in small batches and review why, validate some of that code, think critically, because again, our job is to guide these AIs. It's not for the AIs to do our job for us. They're trying to help us do our job, right? That's the expectation. And then we're going to refactor that code using regular refactor, but we're going to use the AI to help us, and then we're going to refactor our interaction. Okay. A lot of critical thinking too. Some things that we do, we're going to learn and recognize like, okay, I didn't know that. And the big two challenges with AI is if you know a topic, it's a lot easier for you to recognize when the AI is hallucinating because it's very clearly. But when you don't know a topic, you have to immediately be distrustful for these AI because they do hallucinate and they confidently explain things that they think are true or not, like my old YouTube. So the issue there is you have to be critical. You have to critically think and think, how deep in the rabbit hole of research do I go? Which I admit nowadays is a lot harder. If you've looked at some of the comments and explanations from people such as the Cloudflare CEO, a lot of the traffic on content has drastically changed in the past 5 years because of walled gardens. It used to be everyone published blogs and forums and they were open and all the content was indexed by Google so you could find anything. Then places like Facebook and Twitter and YouTube prevented, and forums prevented, and a lot of the phone social networks, any of their content escaping that walled garden. So Google didn't really have the ability to index it. So it became harder for you to find it unless you went to that specific platform and prayed that their search feature did this thing called. So it became a lot harder to do critical thinking research because it was divided everywhere and Google became less useful. That's changing again because now these models are being replaced with those search results. So for example, Google on the front page provides AI results from their Gemini model right there. And so people are more likely to use that maybe often hallucinated response to research content. Conversely, Facebook, Meta, they're doing the same thing with that, YouTube and et cetera. So a lot of the research now is being provided by LLMs, and some could argue that some are augmented with machine learning models, which is fine. But the point is that we're no longer able to leverage our critical thinking skills to easily research things. Sometimes it takes a lot of effort. And the temptation is just to say, well, I guess whatever the ASA is true because I'm tired. I empathize. But if you're in software development, the whole reason we're here is because we can think critically. Right? That's our job, is to think critically about these requirements and like convert those requirements that are nebulous and ambiguous into something concrete, such as algebraic types and code that does X, Y, and Z. So interesting way of changing how you do critical thinking. So we're going to talk about that. And I think the number one thing I want y'all to take away from this is that we're going to work in small batches. So whether you use node types, you think TDD is a cult and a bunch of weirdos, it doesn't work. That's fine. But you should work in small batches because the AI and yourself can go off the rails. And working in small batches really, really can help guarantee that if something does go bad, you can take a step backwards very easily. You can do a git revert very easily. And the blast radius of those changes aren't really large, right? So we're reducing risk. And one small thing I found interesting is that we're going to do some code review with the LLM. A lot of times code review, I believe in trunk-based development, but a lot of us work at places that PRs, peer review, or merge requests are just the way of the world. And code review is a lot of tech leads and software developers, senior developers, and juniors' jobs. Your job is to peer review your coworkers' code, give feedback, iterate on that feedback. And some of it is subjective. Some of it's very to the point and very clear and factual. But the point is that those handoffs, those delays cause a lot of problems. So AI really can't compensate because you still have to wait for someone else to use the AI to give code review feedback and their own feedback. And so that code review is just a large part of a lot of our jobs. Interestingly, some of the LLMs using our context file can help us spot things that we didn't spot. So we're not really too much interested in its opinion. It might be interesting, it might be things we didn't think about, but its ability to spot all the holes that the types and the test didn't cover, some of the logic didn't cover, and whatever its training said, if it's seen a lot of code, it can help. And so we're going to use that as an example, as a helper for that code review, not a summary. It's not going to summarize the problems. It's going to help us. It's going to work as a partner because we need to read. We need to understand. If you do a summary, you're going to miss context. The whole point of reading is so you grok it. So let's talk about type-driven development, some of the details about it. We covered some of these topics, but I wanted to break down like what it is and why we're doing it. So type-driven development, why types? It helps narrow your problems to be smaller. The idea of types is to narrow what the code can and can't do. If you ever seen Richard Feldman's Making Impossible Situations Impossible, it's to prevent certain places in the code that could go off the rails, contexts you didn't think of, or situations that could occur. You can prevent a lot of that with types. But more importantly, it allows you to have a language to express your domain in an algebraic way. And the reason I say algebra over and over is that it's very clear that there's only like 1, 2, or 3 paths, right? Rather than multiple with dynamic or things you didn't think about. So a lot of types can prevent you from shooting yourself in the foot. So types are a great way to narrow problems to be smaller and think about your code before you think about test or implementation details. But they also reduce the amount of unit tests you need to write. So when you're thinking about types and using types, a lot of the unit tests can kind of just go away. So, for example, a lot of the mocks that have to know about the details, those can be negated with types. That's why a lot of us functional programmers have mocks. Some of the languages can't even use mocks. Just not how those languages work. They give you types and they tell you what happened, right? And if it worked or not. And so you don't need to assert that it was used in a certain way. It's that usage is built into the types. So when you use it, it's guaranteed to work. It's very similar to like, can you guarantee that gas was used when I turn the car on? Yes. Right. That's how that obviousness is how types works. That's why a lot of us, when we're doing unit tests and stuff from a non-functional language, we find it very strange. Knowledge of the internals or how it works. It also makes you not care about the details of it. And again, we've talked about making impossible situations impossible. Can't crash with a null pointer if you don't have null. Cool thing to think about. Some developers find them fun puzzles. I'm one of those developers. I don't really like puzzles, but I do like building these structures that constrain my understanding, the team's understanding of the requirements. Any deviation of that is something we learned or something we haven't thought about or something that I misinterpreted from the requirements or the user is like, hey, we need this. And it doesn't. So that's why a lot of those types help us simplify what we're trying to do. And we just read the types. We don't have to read all the code. You just look at the function signature or the records and you kind of understand it. When it compiles, it works. That's where that phrase comes from. And it varies on the strength of the type. Golang, for example, TypeScript, which is gradually typed, especially when you're integrating with libraries that aren't typed, kind of typed, use anything. So it's varies. There's nuance, but that's where that phrase comes from. So you have a lot more confidence that when it compiles, you're probably having some good feeling. But more importantly, when it's not compiled, a lot of those compile errors can help you identify what to fix. And so that leads me to, why are we doing this with agentic coding? We're having these agents help us. The red squiggles in code, the AI can find. So normally, if you look at why a lot of people like TypeScript and VSCode in particular, but WebStorm and IntelliJ too, is that they can see the red squiggles. That tells them where in the code they need to fix, so the code starts working, or they finish a feature. Those red squiggles are a visual way to very quickly scan, and it's just a color. You don't have to read anything. You can literally just see red, fix red, code works. Like that's a really powerful thing. Interestingly enough, the code for red squiggles, the AIs can spot those too. I think the difference between the AIs and us is that we typically look at 1 to 2 files. We'll have a split view, or maybe we'll look at the same file, but we're looking at different portions of it. So if you're a lumper or a splitter, if you're a lumper, you have all your code in one file. Elm developers or constant lumpers or functional programmers in general, because they just have a bunch of functions, a bunch of types. A splitter is a lot of times from the object-oriented programming languages where you're abstracting lots of code and lots of ceremony, right? Code that you have to build for ceremony. Maybe the syntax is verbose. So you have a bunch of files that have little bits of code in them. Either way you do it, the human, whether you're a lumper or splitter, can only see so much on the screen at one time and take in so much. AIs don't have that problem. They can see all your files. And in the cases in a secure environment, like let's say a corporate environment where they don't have ability to read your file system, you can drag all those files to the context. So whether you give the AI carte blanche ability to read everything, or you have to manually drag the files, the point is they can do all of the file in multiple files, and they can see those. So that's a very powerful concept. They can see all the things you can fix instantly, way faster than you, and way larger breadth. That's kind of neat. So types enable that, right? It enables the AI to spot the errors from far away. And if it misses them, you can visually see what the AI missed. So conversely, if the AI is hallucinating or the types are off, you can spot and say, wait a minute, that red squiggle was actually incorrect. It's a false positive. There's nothing wrong with that. Something's off with the types here, or I don't have an understanding, or the AI. So they can also work in reverse. They can spot, misunderstandings. They're not just problems. It also helps narrow the problem the AI is trying to solve. So the issue with a lot of these AIs, even with the larger context windows, is they're more likely to hallucinate. And it just depends on the model. But we've noticed that even the larger ability to think, they are now pattern matching on larger data sets, which more likely increases how likely they are to get the wrong pattern match, the wrong guess, the wrong, thinking path, whatever you want to call it. And so having that narrowed with these types prevents them from only going to 1, 2, 3, or 5 paths, which is amazing, right? It really helps keep them in check and keep us in check and simplify how much we have to do. When you start working out, whether you're doing bodybuilding or powerlifting, the goal is to progress. So I'm not talking about CrossFit where you're just exercising to just stay fit, right? I'm talking about training where you're trying to get stronger and trying to improve over time. And the goal is to increase the weight. Now, eventually, you're going to, get new gains. You're going to get really strong and a lot bigger. Depending on your genetics, like me, I don't really grow much, but other people, they have that Cro-Magnon or that Neanderthal gene, and they get really big. Especially if you're a guy with testosterone, and eventually you peter out, and so you start adding instead of 5 pounds every week, you're adding like a washer or a penny. Right? You're adding little bits of weights, but the goal is to increase how much weight it is. So your muscles the muscle fibers break down and grow back, right? And so eventually that progression of getting stronger is there. We have the same thing in our heads as developers that when you start, you can only have a few concepts and a few lines of code that you can really understand. And as you keep doing it, you get really good at understanding more lines of code and more concepts and keeping track of this file calls this thing that calls that service from that team with that microservice. You get a lot, your brain just stretches. It's a very similar muscle. And so the AIs can do that, but sometimes it causes problems because they pattern match on the wrong thing. So we can get better, but sometimes the AIs don't get better stretching that context. And so it's an interesting dynamic where it's good that they have that context. We're going to narrow within that context of our code base. Hey, just focus on this part for right. And sometimes that seems to really help, especially Claude, a little bit of ChatGPT. So yeah, oh yeah, last thing. The types are correct. We have flexibility in the code input, which is very, very important because a lot of functional programmers, you'll hear them talk about like don't using debuggers. Like sometimes like logs, not for observability purposes, but just like figuring out why the code isn't working. The reason is because usually the types are correct or the code is based on expressions like mathematical responses. It's not imperative. This does this, I store this variable, then I iterate the loop. Like the how, we don't really care about. We're more about what is the type. The function says that it takes in a number and gets a number. That's what it does. We don't care how it does, right? Assuming those types don't, which will also. So the reason that's important is that the AI has flexibility in there. They don't have to get the implementation exactly right. As we're refactoring code, we're allowed to improve it, as is the AI. So if you want to have the AI write all the code and you just write the test, it can do that. It just needs to match the types. You don't really care what's happening underneath. To give you an example of this, there's a guy named Alex B. I can't pronounce his last name, but he's very, very just articulate about testing and development strategies. And he's one of those guys that's on the opposite extreme of a lot of the TDDers, where he says, when's the last time any TypeScript developer has actually looked at the JavaScript code it generates? Like, can you remember the date, right? And for me, I think it maybe was a year ago. I don't, but before that, I have no idea. I never really look at the JavaScript TypeScript, and I don't care because like that the compiler handles that, and it doesn't really matter. Like that's a bundler thing. But for some people, that's a big deal. They really care about the bundler size, and it can impact how much their e-commerce makes because that extra millisecond, can magnify to millions of dollars. Like you think of like Amazon.com and things like that. So for some people, it's still an important topic. But the idea is, if it is a problem, then have the AI fix it. Like if the code is slow, have it make it faster. If it's incorrect, tell the AI to fix it. Why was it incorrect? I told you to do this, whatever. And so his ideas are really challenging a lot of even what TDDers think, because we're not even writing the test. We're just telling, very similar to the vibe coders who are iterating requirements. He's thinking about, here's the specs, you implement it. Like I'm not involved in the implementation, right? And you'll hear a lot of object-oriented programmers sometimes say the same thing back in the early 2000s of like, those are implementation details. We're more interested in. And so that kind of idea is the extreme of having the AI do that. Whereas a lot of us from the TDD sphere that want to be involved, we're interested in owning the test for the requirements' sake and understanding, and the implementation details is the AI. If that's the case, the types allow you to have a really good barometer to check if the AI is correct or not. It's very black and white. A lot of the behavior of test isn't always black and white, because maybe if you filter it on this and there's nothing back, you should get an error, right? It's not always clear what that behavior should be. With algebraic types, it's a lot easier to see. That's not an integer, that's a string. So those types give us implementation detail changes. And if we change the types, it's very clear for the AI what to do. That's why it's not. Okay, let's talk about TDD. I know I've talked about it a lot on other sides, but in particular, why are we doing this? You want to eat your own dog food. The whole point of code quality and code craftsmanship is what Kent Beck and a lot of the other, I think it was called software craftsmanship. I know that term has a lot of people frustrated, but the idea was to care about the quality of code. A lot of increase of software development brought a lot of new faces, but it also created a lot of startups and an explosion of software eating the world. And so we started seeing more software. Inevitably, some of that software is not going to be good. So it can create this negative perception that software is not any good anymore, which isn't true, but you can see a lot more examples of it being bad. So I can see where they would draw that. And the issue with that is that it made a lot of people sad, because they said, well, has no one told you to do a good job? Has no one told you to take pride in your work? If you don't understand something, take ownership of it. And so that idea of eating your own dog food is a big deal. Perfect example is like the BlackBerry CEO had never used an iPhone. Do you know what BlackBerry is today? Like some of you will never know. It was the device for corporate, like having the ability to do on a keyboard and type your emails out on the go was just the most amazing thing before we had, phones that had screens that you could touch. And so they just died because they just, didn't eat their own dog food. Some of these software people that are building products, the good ones, even if they're vibe coding, the ones they built for themselves, because it solves a problem that they take very personally and they're passionate about. And because they're passionate about it, if they hit a challenge, it's very easy for them to power through, because they are enjoying, what the possibility of getting this to work could do for them, right? They're not burnt out because they actually enjoy it. They're so close to the problem, it actually motivates them more. TDD allows you to eat your own dog food and say, wait a minute, I don't like this code. Testing it's hard, using it is awkward. Maybe I should design something cooler. And so a lot of developers will get inside the code and play with it, and that's great. This is just, okay, if you're going to write this function, what about when you go to use it? Like in another function that you're going to go write or another class? Like, do you like it? And so eating your own dog food, TDD really helps say, wow, I don't like this code I wrote. I'm going to build something else. So you still get that same feeling that people who've used TDD and it didn't work for them for a variety of reasons. One of the criticisms they have is that they don't like the code that it produces, or they don't like to feel the code they're writing. And so we do get that in TDD, especially in the Chicago method where you're building all these small pieces. So we're going to eat our own dog food. We're going to say this code is good. It's tidy. It's clean. We can read it. We feel good about it. We feel other developers would like this API. They wouldn't have to learn a lot. It abstracts. So, all those qualities that we perceive as good. Whereas Tim Ottinger, I think he's one of the co-writers of the Clean Code book. Your version of clean code is because you perceive it as clean. But your audience, either A, doesn't know what your perceptions of clean code are, so you teach them, or B, they have different values and perceptions of what clean code is, and you learn that, or y'all work together and kind of compromise and arrive on a shared vision of that, right? And so either way, the code that you write, you should like, and it should be good. And so eating your own dog food says, yes, I like this code, or I and again, that comes to designing code you want to use. So again, we're not just writing code, we're designing it. And if we don't like the design, we change it. The tests can very quickly scream out to you, this is hard to test, or this abstraction makes no sense, or I'm confused about what I just wrote. And so what you do is you design the code you want to use, and then normally you would write the code to make that vision come true. But in this case, the AI can help you. Sometimes you don't have to do it if you. The code is easier to test because you wrote it to test first. So a lot of people view test as like either A, I'm being told to do this, B, some senior dev said that it's important, or C, they've actually found value, or the test found bugs, or they've been working on the same project for 6 months and a test failed that they haven't seen ever fail before and helped them catch a bug before they went to prod. That's a side benefit, and it is an amazing side benefit of test-driven development. But when you're dealing with code that you might have to add tests later, it's hard because the tests weren't designed to be testable. They were more interested in getting the code to work, or they were on a deadline, or they didn't know anything about tests or how to make things testable, or they didn't care, or it wasn't a law at the time, but now it is a law to make, tests at a certain coverage level. And so if you just test it first, it's not hard to test because you designed it to be testable because that's the process. Kind of nice. The most important thing is you refactor the code safely. So I used to think refactoring meant, making the code better, that whatever your perception is better. But refactoring actually is a very scientific term, as it means you have a test that's green and you change how the code works internally, but doesn't affect the behavior, AKA the test doesn't go from green to red. That's what refactoring. So it actually has two meanings I've also learned. It also means that if you do the simplest amount of things to make the code green, that could just mean return 1. So if the function's supposed to return a number and the unit test says expect the result to be 1, then you return 1. And you just ignore the inputs, right? So, but we need to handle the unhappy pass and the unhappy cases. Well, cool. We'll do that when we write those tests for it. But sometimes we can change how it just returns. Maybe we don't want to use a return keyword. We just want an arrow function to make it more readable. Whatever that is, you're going to make the code more real, cover more cases. So it's not just making the code better. It's continuing its early development. So that's kind of where we start with refactoring. So refactoring kind of has two interesting thoughts. It's there that it also ensures, we've talked about this, that you don't break anything later. The behavior is how the code works. That's different than what the types say it's supposed to return, the parameters it's supposed to take in, and the variety of results it could possibly return back. Sometimes the behavior is we expect it to work like this. They're a little more higher level, more in human language. But whatever that is, you're going to capture that in those tests to make sure that that doesn't break later. And we're not just talking about unit tests. We're also talking about acceptance tests because you can do TDD with acceptance tests too. So acceptance tests are usually for the product owners, for the business people, for the designers, for the user to say, does this application actually work? The tests are more for the logic and making sure that we developers have designed something we like and matches the requirements. So it's a really good indication very quickly because they're fast, but the acceptance tests are slower. So we need both, but both make sure that as we add new features and change things that we didn't break, because you don't want to ship a new feature and then break something up. It also helps you ensure you work in small batches. If you're doing tests first and you're doing all these stubs and mocks and things like that, it can be very tiring. And that's why they always encourage like the 1 minute you make a change, you commit it. and you only commit when the tests are green. So you have things like Husky that prevent you from checking in code that doesn't. There's a lot of people that have very strong beliefs that you should be able to check in like small commits. So if the code isn't compiling yet or it isn't passing tests, that you should be able to check those, small commits in. I'm one of the people that doesn't believe that at all. If the code isn't able to build or compile and the tests don't pass, don't check it in. If you can't make one line of code change that doesn't break the compiler and doesn't break the test, then practice. Or work in small batches. Like adding a console log, for example, is not going to break anything most often. Changing a type will, but the compiler will help you figure out what to fix. Adding a new test for an unhappy pass shouldn't break the other happy pass. Little things like that. And so it takes practice. You're not going to get this immediately. But those tests are going to help you hone that skill. And it's going to help you a lot when dealing with AI. So you think about the problem, you explore it, then learn it, then iterate. And so that's the kind of the whole point of the design part. It's not just about number 2, design code you like to use. It's about, does this code help, if we're doing Chicago, help towards the goal of solving the use case we're trying to solve the software? Or if we explore it, do these different ways of doing it, you know what, heck with the problem. I just like the way this function works. It feels great. I know this is going to rock with whatever it integrates. That could be valid too, man. Your instincts of like working things are very important and right. They're a gateway to your subconscious to say that, your instincts are right. This is right. And you should go with it. So you should always follow your instinct. They're usually right. And then when you learn it, it's like, okay, I think I have a better understanding now that I've implemented it, what the requirements actually mean. Or they made me rethink about what I actually heard because now I have context implementing this algorithm, or implementing a way to get results, or implementing a way to find these records that they're, or process this data from the mainframe. Whatever it is, going through that, you're going to learn it. And then lastly, you're going to iterate on it. You're going to read the same thing with different eyes, with a different perception, with a different understanding. You're going to go back to the product owner sounding more intelligent. Because again, that's the biggest challenge with us developers, is that we're supposed to be horizontal, right? There could be people in the mining industry or the motorcycle industry or the coffee industry, and we're supposed to just, we could write software for all of them. What do you actually know about coffee? Just because you drink it doesn't mean you know that. You're right. I know nothing. I don't know anything about the logistics or how it works or whatever. But that's our job, is to learn how that works quickly and then translate that into working software, right? And so our ability to iterate towards that goal, like if you think of an airplane going from Los Angeles on the west coast of the United States to Hawaii, it's an island out in the Pacific. It's not going to go in a straight line. It's going to iterate on its way, constantly correct its flight path. Sometimes it's off, sometimes it's on track. But it's doing it over time in small batches because it's low risk. And that's what we're going to do too. So the idea of the problem space of learning what those requirements are, that's another really important of why we're doing this, because we want to iterate towards it, and we're going to do it in small batches without breaking a lot. So again, I go back to Brian Finster's The 3 Wrongs of the requirements are wrong. Somebody wrote them down, they spent a lot of time on it, or they spent 5 seconds. Either way, both are wrong. You're going to find a lot of requirements that are just not accurate. You can read it, but even if you've been in the domain space for a while, your interpretation is still likely wrong. There's something you might have misinterpreted or heard wrong, or somebody has a word that means 5 different things in different contexts. And maybe you were just in that other context, you come over and go, oh yeah, that's what that means. But your interpretation is wrong. So you wrote all this code and it's wrong. The other one is the user's needs change as time goes on. And so you need to be able to change that code. The test allow you to change safely. Another example is MIT's study showed that ChatGPT makes us dumber. And the point they were making is that if you write an essay about a topic, you're forced to learn about that topic so you can articulate in words to someone else what it means. The only way to articulate in words is to know what to write. You only know what to write if you understand the concept. If you understand the concept, that you can start articulating it. And if those words don't sound quite right, let's say it takes you 2 paragraphs to describe a concept, you don't even understand the concept after you're reading your own words, and you iterate to learn more about it. Eventually you can summarize it in 1 sentence. That's when you know you've kind of arrived, right? At like understanding. Using ChatGPT, LLMs, any model to generate the essay, they found that those people who did that had no idea about the topic, didn't remember anything. And the incentives are to pass the test. The incentives were not to learn the content. So I don't know what the motivation behind that original point is, but the study showed that that's the black and white result, is that if you use an LLM to write it for you, you don't actually learn anything or remember it. And I kind of, it reminded me a lot of the Arial versus Comic Sans. There was another study which showed that although people's perception of Comic Sans can negatively affect their view of an email or a blog post or a PowerPoint presentation, the retention is actually higher if it's written in Comic Sans because it's harder to read. So although Arial is a lot easier in Helvetica, very clear what the letters are, no fancy serifs, it's just very clear what that word means, the topics mean. You can get through the content so much faster reading that it reduces how much retention and understanding of the topic you have. Because Comic Sans forces you to slow down and really grok what that sentence says because it's so hard to read, you retain it. And so this is why I believe, a little different than some of my colleagues in the industry, is that I think writing those tests forces you to understand what the user really needs. Again, the whole reason that I got in this industry in software is the same thing that my wife did, and she's a designer. And that is, like the original Tron movie, we fight for the user. We really want to build software and that the user just goes, man, this is awesome. It really helps, solve whatever my problem is. That gets us off. That's why we're here. And I think writing those tests and reading those tests over and over forces you to understand what you're trying to really do. And so I think the people who use the LLMs to write the test lose that when they no longer review the code. They just read the test. They also lose context for how it arrived at that test and what mechanisms were in play to make that happen. And so I feel like you're going to lose a lot of understanding of how the software works. That's important, not because, the AI can't do that or we can't automate it that way, but rather, is it doing it correctly? Are we actually solving the user's problem? Like, why are we doing this? And I think that's really important. So thinking about the problem, exploring it, understanding that problem, and iterating on your understanding and on the user's needs, this is a constant thing, never stop. So why are we doing this AI? Well, it ensures it works in small batches. If you do a really small test, single test, you can make sure that the AI can't screw it up. So you don't have to write 50 tests and go, all right, the whole app fails and we have 50 tests. Good luck fixing that. Oh, I'll just have the AI fix it. Yeah, but are those tests even right? Is the implementation details even right? We're going to go really small, not just for the AI, but help us understand. Again, the AI is augmenting us. Eventually, maybe we'll augment the AIs, right? But for now, that's where we're at. As the models get better, we're still going to continue to use them to help us. Maybe they're always going to help us. Maybe we are going to be like Alex and we're just writing requirements and they code everything. That's fine, but the point is we want to do that in small batches so it doesn't go off the radar. If it hallucinates, it's a lot easier to spot. So even if you don't actually know the requirements yet, you don't really understand the problem you're trying to solve, if it hallucinates in a small test, it's so much easier to spot in 12 lines of code in one test or two unhappy paths than it is into this gigantic test suite that it built and the code. It's like, where do I even start to read all this? Because again, 80% of our time, normally, there's a study that was cited on Twitter. I don't know if it's true, but it says 80% of our time is spent reading code. Are you going to spend 99% with AI now? Like, okay, it would help if the AI generated code that's easy to read. Currently, with ChatGPT O 4.1, Claude, they want to generate a lot. Like, I need less code, not more code. Again, code is a liability. It's okay to love your code. It's okay to, get attached to it. People say you should do that because they're afraid you won't be able to delete it. But the point is that code is a liability. You can't write half a piece of code, leave work, come in the next day, and then start writing again. Like, that is not an asset. Like, we want less code, right? We only need the code that we want to solve the problem and everything else. More likely to have a good guideline on implementation details. So if you have a test or even more tests, that seems to help the context to get the LMs like, got it. You want me to implement this to make this pass. You want these types to be correct. Gotcha. Like that really seems to guide these AIs to a lot, basically set them up for success better. So they can't hallucinate, they can't get it off pace, which is just, it's awesome because the big frustration I had was that even if an AI only hallucinates, let's say 30% of the time, the 30% time it does, or the nuanced 20% where it's not quite right or it's a little too much, that ends up costing me, 120% of my time. And so I'm actually less productive using these LLMs, right? Because I have to correct them. So if you want to get to that sweet spot of productivity, you got to make them work for you, so you're not having to constantly review them. Um, and again, the concept of a junior, you're going to have this bell curve where you're going to spend a lot of your time correcting, but eventually you make them into slayers. You know what I'm saying? If you're a tech lead, you get them rocking. They're going to rock. They're going to be part of your team. They're going to be checking your PRs. They're not going to have those preconceptions that you do and say, "Hey, dude, why'd you do this?" I'm like, "Dude, I didn't even think about it." Like, this is why young, fresh, non-cynical, no agenda, young coders, or even old coders. My point is like inexperienced are just wonderful, right? They're a wonderful addition to the team, and that managed diversity is proven, scientifically proven to lead to better results. So you don't get that with AIs. They don't learn, right? And so we need to constrain even more on making them successful. And so it having these tests really constrains that. However, the models get better, right? Like I think a lot of us would agree that Sonnet and Claude Opus 4 is a lot better than some of the older models. And so we can expand on that and learn on that. And these tests help provide really good guidelines and guardrails for that. Some people find the red green of regular refactor the boring part. I find the green part super frustrating. I like the red. The reason I like the red, so okay, I get really excited about this. The reason regular refactor is a thing is because it was really hard for people to understand TDD, and they boiled it down to regular refactor. They tried BDD because like the whole concept was like hard to understand, and this was because the world was at the time was transitioning from waterfall development to agile, right, where they do really small batches of iteration. They don't waste months on requirements. They spend like days to hours, maybe a week in bigger companies. But the point was get something out there, iterate on it so we all understand the requirement. A lot of the people didn't live through that. That's why waterfall is kind of making a comeback because they think it works. Like, oh, I'll just define my requirements correct up front and then give it to the AI. It's like, dude, waterfall doesn't work. Doesn't matter if it's AI or not. Like AI is, even if it was a smart AI and it could learn and it didn't hallucinate, it's still going to do it wrong because of Brian Finster's 3 wrongs, right? So waterfall just doesn't work. But regular refactor was kind of a simplified thing more for programmers and say, make a test, make it fail with confidence. Because some of the worst tests are the ones that are false positives, where they go, everything's good. Everything's not good. Or this failed. It didn't actually. And so that's what you're trying to get rid of first, because those are the most dangerous. So we get it failing with confidence first. And then we say, all right, if it's not true, and then we go make it true, it should pass, right? That's the green step. And a lot of people think green step is like write all the code, but it's not. It's literally like if you have a type or function, you do the simplest thing possible, especially with really complicated types. Sometimes it's hard to do this because you actually refactor to make it so simple to return this stupid hard-coded value, right? You have to build like a gigantic record just to make the test pass. You're like, all right, I made this 100-line JSON just to make the test green. Am I successful? And like, yeah, you're successful. Now keep it green as you refactor on it. So some people find different parts of those steps. I think most people, except for Alex, really, really enjoy the refactoring, like making the code faster, making the code more elegant, making the code more functional, making the types better. Whatever that is, that's what most of us enjoy. And so I'll see if I can find the presentation, but there was a user group meeting here in town at the, Richmond JavaScript user group, and Momin was talking about the things that bring you joy, you do that. And the things that are boring, the AI do that. So for him, it was like a portfolio site. He did a little bit of it, but the AI kind of degenerated. He didn't care about the code. He cared about the end result that he showed employers. Like, you want to hire me? Here's what I've done. And he can kind of tailor it to what the employer is. But more importantly, he can also filter the results if the employer wants to see specific things. And so I think Alex is one of those people who's more interested in those requirements and tests, People like me, I'm more interested in the refactoring part. I hate the green part. So if the AI can do the green part, great, right? Now, what the green part is supposed to be simple. We're going to iterate on that. So yeah, you get to do the fun part. For me, that's refactoring. But some people, they actually, I sometimes do like the red part because I get really frustrated when I don't actually know how something can fail. And so I find that because I've been burned, by bad test suites before. The vibe coders know this. This is why the vibe coders, even if they're not doing test development or test after, they still have tests. And that's because they want to guarantee the AI didn't break anything. They're a little more likely to allow the AI to just do whatever. But they need to know, does their code still work? So test for some of those vibe coders allows them to. This is more of a code wrangling thing. If you're familiar with Simon Wardley, he kind of calls it code wrangling. We are kind of trying to, wrangle the crazy AI like a bull that the Cowboys are trying to wrangle in there, or they're trying to get a herd, going in the right direction. That's kind of what we're doing here if you're doing multiple AIs. Refactoring gives the AI better context. So as you refactor the code, you can give the AI context because it can read your code, but also in the session, you can tell the AI why you refactored. And lastly, take that refactoring and put it into your context file. So the AI has examples of code and context that it can see. So when you start giving it questions, it's like, yes, I won't write the code that way again because you yelled at me before about it. So again, I know they can't really learn, but they kind of can learn from those context files, and you can learn how to better work with it. And you can tailor your responses to a particular model. For example, like I think Gemini and Claude were one of the ones that really, really like the explicit directions at the top, a bunch of text, and explicit directions at the bottom. To say, like, I said, here's what I want you to do. However, here's nuance, but don't forget this, right? So don't hallucinate. If you're gonna hallucinate, tell me why you think that. Tell me the steps you arrived at that, and I can help correct it, right? So you see a lot of AIs nowadays will put bullet points of how they arrived or their task list, and so that gives a little more transparency of how they're arriving. It helps you correct the incorrect route they arrived at a conclusion. So the refactoring gives you, so we just talked about this. The prompts, it helps, you fix the prompts. Okay, so let's talk about some nomenclature because a lot of the words we're using are new. And the biggest problem that programming has in general is no one has good nomenclature. There's no scientific words for any of this stuff. What is good code? It's different. Everyone has different perceptions of what good and bad code is. I'm going to give you my nomenclature so we're on the same page for this video. So if it's incorrect, let me know in the comments, but this is how I'm thinking of it, okay? So AI means some computer program that acts smart. In this case, we're going to refer to Claude, Gemini, the models with the command line interfaces they have and the chat interfaces they have as how we interact with them, okay? Most of them are large language models. So they're not actual what a lot of us X-Gens thought was artificial intelligence. Artificial intelligence is supposed to be like a smart thinking machine, right? Terminator, things like that. And that's not what LLMs are. They don't reason. They're just pattern matching. If you're a functional programmer, that has a very simplistic algebraic way of doing things. It's like the answer is 1, 2, or 3. You didn't think to arrive at it. It's literally hard coded 1, 2, or 3. It's math. So there's no brain or thinking or reasoning or learning behind that. But that ship has sailed. Everyone thinks that LLMs and AI are kind of the same thing. Agentic coding, based on what I can tell, it's when you code with or have an AI code for you or with you. So I use it as kind of like pair programming, except unlike pair programming, the AI isn't really driving. I'm driving. I'm more of like, the driver and the navigator a little bit. They're driving a little bit. But the point is you're working with AI to code alongside you. You didn't turn ChatGPT or Copilot off. Vibe coding is when you have the AI implement everything. And sometimes you can just tab, sometimes whatever. There's some nuance on how much testing you do, how much actual coding you do. But the idea is that some have tests, some just have, they enjoy refining requirements and context files until the AI gets it right. And so they iterate towards, sometimes the AI provides something and they go, oh, actually, that is right. Good job. You taught me things. And some people really get off on that, especially, coders who haven't done this before, haven't flowed with requirements or changed things. Code wrangling is, like I said, what Simon Wardley calls a developer. They're using AI to help them code instead of the AI doing it for you. So code wrangling is what I think I do, where I have very narrow types and tests to guarantee the AI implements those details. and then I review those details, and we work in very small steps. So we're kind of guaranteeing it doesn't, the cow or the sheep are in this very aimed pen to guarantee we can wrangle where they go. Now, the model is the version of the LLM you're using. Like ChatGPT 4, I used at work for, I think, a couple months, and then they changed it to ChatGPT 4.0, which is from last year. We got the 4.1 model as well for chat. Claude 3.5, another good example of people love it, but they don't like 3.7 for some reason. Claude Sonnet and Opus 4, Gemini from Google. So those are the different models. As new ones come along, we're going to use new models, but none of the rest of this stuff kind of changes, except for the learning. Hopefully, someday we're going to reward-based models that we don't punish. Prompt is the instructions you type in the chat that you want the AI to do. So when we talk about prompt engineering, we're trying to create prompts that make the AI give us what we want, because it's not always deterministic, right? 1 + 1 is 2, and it's always 2, regardless of context. That's determinism. Non-determinism is some days it's sunny, some days it's not. Some days the app say it's going to sunny, but then it turns rain, and it's always random. Like, you don't always know. Sometimes you do know. That's non-determinism. Like, you can't always guarantee it's the same output. And so AI sometimes, even with the same models, will give different output because the time of day changed or your prompt changed just by one letter. And so that prompt, those instructions you give the AI, are a very specific thing. The code hint or code completion is what I don't use with AIs, because they get way too aggressive, and it stops your train of thought of thinking about what the code wants to do. You're thinking about, all right, it's going to do this, and I want to do this. That breaks the flow of your thought process. And so code hints are kind of the opposite. What the vibe coders like, because sometimes they'll just tab and they go, yep, 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 and we're done. And the test passed. Good job. Commit. And so that's a very different way of working. I turn those off, but some people love them. The context is what the AI has in its memory space, if you think of memory space. So what it remembers about your conversation, the code you're writing, and its ability to add multiple concepts at the same time. Newer LLMs have larger context, which is a pro and a con. The context file is the instructions that help set expectation to the AI on how you're going to work together, how the code should be written, and the methodologies and special instructions follow. It's also where you put your brown M&M, and we'll talk about what the brown M&M is in a minute. That's my intro. That's what we're going to do. Let's start coding and show you how you do this stuff. I've got VSCode installed. I got Vite installed. I got TypeScript installed. I got a GitHub repo. We're going to start from the new branch and start pushing code in there so we can see the lineage of it. You can look at the other branches to see some of the experiments I did and how things change over time. Okay, we're in VSCode. Let's take a look at some of the configurations I've done first, just so you can see. So in our package.json, we have a command called tdd, and it just runs Vitest and watch. So as you change files, as you change tests, it'll automatically run the code. But it also does it when the AI does it. So if you're going to do edit mode or agentic mode, where you talk to the AI and it can modify the code on your system, it's going to save those files after you accept the changes, and it'll rerun the test. So the AI can see that, you can see that. So we're all on the same page of what's actually going on. The compile is just for TypeScript, and the start is to test our API. We're probably not going to do that, but we should. The TS config, the only thing to note is I changed the target to ES 2024 because I like to play with some of the newer JavaScript. We do have strict mode on, but we are compiling to Common.js because I think the ES6 modules for Node, especially in Lambda, are just a horror show. So Common.js is a lot more fun. Our out directory is in dist because I don't want the AI to get confused, or myself, about JavaScript versus TypeScript in code and context, right? Dist should be a compilation folder. This is a very common thing people do because they're shipping those bundles to the browser or Node or something else. And so it helps the AI being trained on that data set to know what that is. So we're just going to, in that case, go with convention. And strict. So yeah, we're not dealing with any nonsense. We're going to be really strict when it compiles at work. Okay, so we have nothing here in this file. So let's do two things. First, we're going to run tdd, and it should fail because there's no tests in our index test. There's like nothing there. So let's just open the test. Next, we're going to open Claude. Say, what's up, Claude? And we're going to say, sup. Make sure he or she works. Hey, what can I help you with? Okay, so it's speaking English. That's good. So the first thing we're going to do, we don't have a lot of code, so normally you would do this after a while, but that's okay. We need to give Claude a context file, and you can use these same techniques with ChatGPT or Gemini. They all use some kind of configuration file. A lot of the newer ones are also using documentation files. So you'll find like the effect library, for example, is one of the bigger ones I've seen do this, where they provide their documentation on their documentation website as a text file. So it's a lot more easy for the AI or LLM to consume the docs. So when you're reading locally, whether you're like, for example, we're using Claude here, which can read everything. I'm in a very locked down environment. I can't read anything. I have to manually drag files in a safe way so it can get context. That's important because from a security perspective, but also it gives the AI context of just what you want. And so instead of using its model, I can say, here's the docs to use. Okay. So to do that, we need a prompt. One of those prompts for ChatGPT is it's in the GitHub folder /instructions.md. For Claude, it's a Claude MD. And so they all have the concept of a context file. So we're going to say init. It'll initialize a new Claude file with code base. It'll do a bunch of things and then make a Claude MD. Now, one interesting thing about this is that whether you're using Claude like right here or using ChatGPT or some other model in the lockdown environment, I've seen a couple of them, is that the session, or I've opened this window and the AI is remembering things as we type, the AI can actually hallucinate that it's still in a session. And you can literally see changes to a file that you made and it just doesn't know. So let's accept this file and we'll talk about that. So what you need in addition to this file is something called a brown M&M. So let's accept this. This sounds good. Sounds good. Say yes. It'll go ahead and save that file. And it'll have Claude. So it now says that it's got essential understandings of like development. It kind of inferred I'm doing TDD and TypeScript and Vitest, which is good with functional programming dependencies. That's good. But when I ask it stuff like, what file are you using for context? Or a prompt related to, can you read the file? Some of the AIs and LMs say, yes, I'm reading the GitHub folder /instructions.md that you provided. Or in Claude's case, I'm reading the Claude MD file. And so it's like, I analyze the files and I'm using the Claude MD files content based on parameter, right? Sometimes you'll change it and it won't pick up the changes or it's not actually reading that file. So you need to create a brown M&M. Van Halen was a rock band from the 80s. And one of the things that they did was they had very just amazing shows. To do that required a lot of equipment, a lot of electrical engineering know-how, and good structures and carpentry and engineering to make sure that it was safe to do these crazy things. And so they would go to these venues that either didn't have the staff or equipment, and they always couldn't tell that. It was unsafe for them, it was unsafe for fans, and it would also kind of ruin their reputation, right? The whole job is to be Van Halen. And so they would write these long pages, and the concern was that they didn't read them. And so they wanted an easy way to tell if somebody didn't read it, right? Because if they didn't read it, they could say they read it, but then little details that were really important in this 20-page or whatever size doc it was would be missed. And so they had a stipulation in the middle that said in their dressing room, they want M&Ms in there with all the brown ones removed. And so when they would go in there, if they saw the brown M&Ms in there, they know they didn't read it or didn't read it enough with detail that they cared about the detail. And so they would trash the venue and do horrible things. So they got a reputation of like trashing venues with their crazy shows, but a lot of it was retaliation for putting the fans and themselves at risk. And I've used this technique where if I write emails to clients or executives and I want to make sure I know if they read it or not, some of the details I thought were important, I would put brown M&Ms in there, usually non sequiturs like chicken pot pie is the worst dish ever. Do you agree? Or something weird that had nothing to do with programming content. And if they didn't respond, either A, they did read it and were just ignoring me as a weirdo, or B, they didn't read it. And so it was kind of my way of brown M&Ms. So you can use the same technique with AIs to recognize if they're actually reading it. And so one way we can do that is there's a couple ways. I'll show you the normal way and the way I do it. So the normal way is, right, you can either put it at the top or at the bottom. I'm going to put it here, how to talk. And we're going to put one bullet point, and we're going to put the battery emoji. Battery. There we go. And I'm going to say prefix all commands, or I'm sorry, responses with activate. I'm going to hit save. Now I'm going to talk to Claude and see if it actually read the Claude file. Because again, it can hallucinate and you'll find it like, yeah, I'm good. I read the Claude file. I see your updates. And it doesn't see your update. You know it worked if you see your brown M&M, right? So that's one way to do it. Talk like. Now, I know some people find this obnoxious. It's fine. I kind of ignore it after a while. So I'll say, hey, now you see it's talking like a pirate. So that's your brown M to know that the AI is not hallucinating and is actually reading your context file. Cool? Okay, let's start writing a test. So what we're trying to do, if you don't remember, is build a AWS Lambda get API that's just going to get a list of people. Lambda get API. And we're going to describe our first function here, and that is to do a health check. So if you're not aware, a health check is something you do with infrastructure to recognize if your machine is healthy. In the server days, whether you're deploying a server, it could be an EC2 on AWS, for example, or it could be a Docker container in an EC2 behind ECS or Kubernetes. The goal is, does it work? Because sometimes you can have multiple of these on multiple servers. And what you're going to do is whenever you change code, you're going to bring new ones in, make sure they're healthy. If they are, you're going to start directing traffic as they stay healthy for a while, and then start getting rid of the old versions. So that's how you go from version 1 to version 2. If they're not healthy, it's not going to spin them up anymore. It's just going to stay on version 1. And so if version 2 works halfway, but then starts getting unhealthy, they'll get rid of those and go back to version 1, which was healthy. Lambda works the same way. Even though Lambdas only are alive for about 100 milliseconds, assuming you don't have a lot of traffic, you still want to recognize they work, right? And the one way you do that is a health check. You just make an HTTP call and say, yo, it's like a head, right? Head call at health and say, are you there? Give me 200, right? The goal isn't really to talk to downstream systems. Sometimes it could be, but the goal is to just respond with a 200, go, I'm good. I'm good. So like, are you okay? I'm good. That's really what it is. So we're going to say health check. Should respond with a 200. And this is going to be async. All right, so for our health check, we want whatever the result is from the health check. It's going to take nothing. We don't really care what's passed into it. We just want to know that the result is a status 200. So we'll say result status code should be 200. Cool. So that's our basic health check. The test doesn't pass because it's missing a lot of this stuff. So let's import it. And it doesn't know, so let's help it out. We'll go above this just to show the importance. Describe from Vitest. And we'll do the same with the it and the same with the expect. Okay, so now the only thing it's not aware of now is that it doesn't know what health check is. So normally I would go down and implement this and go, okay, this is what the test expects health check to do. So we've got the red phase of regular and refactor, but we're going to ask Claude to do it instead. So I'm going to tell Claude, now you don't have to highlight the test, but I'm going to say implement the failing test. So it's going to think about it. It's going to read my code and say, all right, I'm going to go implement your failing test. And it's going to define the steps that it's going to do and then work through each one of those. In the middle of these steps, it's going to ask me to approve some of the things that require actually writing code, changing code. And I'm going to be like, cool, yes or no. So I'm at this point kind of as a pair programmer. So the first thing you notice is that it's importing the health check because it doesn't exist in the test. So yes, I need you to import health check from this test file because it doesn't exist yet. So that's step 1. So the test failed because it's like not a function, so undefined. But then it did something interesting. It noticed what I meant to do was that the status code should be 200. I forgot it. And so this is a good and a bad thing. Remember how I told you that the files, the models want to do too much sometimes or go too far? This is an instance of it knows better. And this is where I think it's augmenting because everyone knows status code 200 should have been 2B or 2 equal, depending on what testing framework you use. I just forgot because I was talking. And so this is a good example where it can see multiple files, but also it knew what I meant to do. And because I know better, I go, yes, this changes what I meant to do. Good job. You spotted something I didn't. You are now augmenting me and error correcting me. This is a good use of AI, okay? So we're going to accept this one. This one's good. It's okay that it fixed a test. Again, we don't want AI writing our test, but technically it's correcting it. And we approved this. So we're okay. We reviewed this. This is good. So I'm going to allow that. It's going to save it, rerun the test. It's still failing because it hasn't implemented the health check. So it's going to think about how to do that. It's going to create the API gateway event from basically if you've ever used AWS Lambda, there's 3 ways to invoke an event. They all get a JSON file. And the JSON, or in this case, object, always has the HTTP method if it's a get or post. It has a path property that kind of is like /health or /cow or some big long path. Query string parameters is usually an object that is automatically parsed for you. So all the URL parameters you put, it's in there. And then the body is either empty or not. And those query parameters are usually just a record. And there's no guarantee they have values in there, but they're usually a string. And then the API get response, what we send back to the API, in the Lambda's case, the contract is you throw if you have a failure, or you respond with an object that looks exactly like this. It has to have a status code, a body, and headers are optional. Headers are just, again, another record. So I don't really like these types per se, but they're okay. They kind of indicate what an API gateway event, and we're going to need them better. So these are good types to say, all right, this is what our event's going forward, and we can improve them. So these are the types that we would think about. Now, the health check is going to respond with a minimum amount to get this to pass. That is hard-coded status code of 2, and then JSON stringify some message. Now, I didn't tell it to send that message. I don't need a body for health check, but that's pretty funny. So sure, why not? We'll keep it. So yes, that sounds good, Claude. So it's going to save that code here, rerun the test, and you can see we're now in the green state. So we went red, green. Now we get to refactor. So we're going to take everything that, Claude did. It's fine. It's going to run tests just to make sure it passed. But I don't really care because we're running TDD. So this is good. This is pretty good. It did the minimum amount to make it, and it returned the correct type, which is a promise API gateway. So far, so good. The reason you can get away with this is because it's an async function. Okay, so great first step. We wrote a test, and we asked Claude to implement that test to make it green. And now if we wanted to, we could refactor. The only refactoring I'm going to do is just take out the body. We don't need the body. We just want this. We're going to explicitly say the body's null at this point, or undefined. Is it undefined? I always forget the type. Oh, body string. Yeah, I'll just say an empty string. We don't need a string. Okay, so we refactor it. This is good. Really small batch. So again, little small code. The types are really the only thing that's verbose about this. And so we're gonna check this in. So we're gonna say we got our Claude, how to talk. We got our first test, and we got our first implementation. So we'll say initial commit. It's good to go. So that is a small commit that took us about 10 minutes, 15 minutes, just because I was talking about it. And you'll notice that we're working in these really small batches. We're going to do a brand new function that kind of implements our ability to get people. And so let's think about people first. So people are, what's a person in our case? A person is going to have a first name, which is a string, a last name, which is a string. I don't know. Claude, what do you call the difference between a dog and a human? Is that genus or something else? So this is where programmers are horizontal. We are supposed to learn something new. So I'm going to ask the AI instead of Googling, like, what's the difference? What's the correct word here? Because again, there's 2 hard things in programming. Naming things, race conditions, and off by 1 errors. Get it? That was 3, 2, off by 1. Between dog and human would be the species. All right, so we're going to say species. Got it. Well, wait. Species? Humans be Homo sapiens, dog be Canis. Perfect. So we're going to say species. Species. And we're going to create a union type. Would be either a human or a dog. So we have species. That's a simple union type. It's not discriminated union, but it's simple. There's no data in it. And so that would be our species. Cool. So I don't know if this is correct. Normally critical thinking would mean you go research it yourself, but I don't care. First step is convert this to Zod. So we have a very safe way to parse it, and it's type safe. The problem is I don't know. So let's see. Let's see if Claude can change our types. Change the types to a Zod type. Let's see if it changes just the person. I selected it. We'll see if it's smart enough to. I probably should have specified just person species. Maybe that was a failure on my part. No. Change the person type and species type to Zod. Cool. So you got to be more explicit. Fine. I can do that. I would rather learn how to do that versus do it myself because I'd still be in the middle of converting to Zod type. Okay, so it's going to import Zod and it's going to delete those. It's going to get species schema as an enum. I don't want it in enum. One thing that I don't use is enums. And the reason I don't use enums, I use union types like this, is because a lot of times union types, by default, don't compile to the source code. So the types are there, but they are not actually in the source code, where enums actually create source code. Now, not a big deal for some small lambdas, but if you're doing a monolithic lambda that has multiple routes and the same thing, all those enums are not in the source code, which deals with your startup time in lambdas. Now, you can use const or as const and other ways to make sure the enums don't compile, but enums can't have data in them. Unions can. So if you expand your species to actually include data, that's one thing that unions can't do. So we're going to go fix that in our context file. You put it at the bottom, it's wrong. And so here's what we're going to do. We're going to go to our Git. And so now we don't have to search for code or look for code. We can just say, hey, just undo this, discard the changes. And so again, working in small increments, it's very easy to undo something that went off the rails. I thought it was a good idea. It's not, right? And so again, this is why small batches are great. But let's fix our prompt real quick. I'm going to hide this. Commands, project architecture, TypeScript. Prefer union types over enums. For example, instead of creating a species type like an enum, a TypeScript enum, let's be explicit here, and we'll put a code example. And so this is what I would tell a junior. We prefer union types because they, by default, don't compile into the code, and they have the potential to have data with them. And just like enums, they have exhaustiveness checking. So they're good data type by themselves, but they have the potential to include data, which is really good. If you had discriminant unions, you can safely access that data, unlike records, which put you in negative situations. So unions are good for a lot of things. So we'll say type species. In this case, it's enum species, excuse me. And we'll say human, dog. Instead, you should utilize a union. TypeScript union. And we'll go TypeScript, give it an example in Markdown, type species, ooh, it's misspelling, species. And I'll even format it the way I like it formatted. So a human and dog. And then let's just ask real quick, Claude, does the updates I made to Claude MD make sense? Let's just verify he or she or it understands what the heck I'm talking about, because I'm a little worried. All right, so let's see. How to talk, yes. And the TypeScript guidance about preferring union types and even spot on. Lightweight, better tree shaking, explicit back to string values. Yeah, whatever. That's fine. Cool. So let's do it again. And we'll just do type person, first name, and last name. And so again, you'll notice I'm redoing something here, but what I've learned is a better way to interact with the AI, a better way to be more explicit about what extractions I want from a prompt perspective. And I can incorporate those expectations into the context file, right? That helps it learn, whether it's Claude, Gemini, ChatGPT, doesn't matter. So say species, keep doing two eyes, species. And we'll say human and dog. Okay, here we go. Change the type person and type species to Zod types. Now let's see what it does. So it changed to Zod, but it's still using enum. We'll have to fix that. However, notice we said types. We didn't specify Zod types. So let's delete this. But we're going to copy this in a clipboard. And we're going to iterate again on the schema file. Let's go to our Claude MD and go down to TypeScript and say, now notice we have TypeScript here. Let's do a separate section for Zod within the TypeScript. So we'll say TypeScript uh, creating types. And we'll put another subsection and we'll say Zod. When creating types in Zod, prefer the union instead of the enum, since our TypeScript types prefer enums. Sorry, unions. Cool. Let's try again. So I'm going to hit up. Do the same prompt, but with different context. And so let's undo that save. Go to the index.ts. All right, so now it's doing a union with a Z literal. That's perfect. So I do know how to do unions in Zod, so I don't have to verify that this is correct. But it's taking a literal string, converting to a union, in a literal dog, all capital. So the JSON has to match this, which is perfect. And then this piece is good. The good news is I left the Zod type so it doesn't put the import in the wrong place. And so it's doing a type of inference. So that's great. Yeah, this is fantastic. So you can see how we've iterated on the context. So now it's giving me the code I want. But the good news, I only have to do that once. This isn't a prompt thing that I had to do multiple times. Now when I prompt in the future, I never have to do that twice because we've got it in the Claude MD file. We've checked that file in, and now the AI knows what I'm wanting, specific requirements on how to generate code. So let's, we can see the test still pass. So let's check those types in. So we can see the changes to our Claude MD about how we want to do types and how we want to do Zod. And we have small changes on just the implementation detail for the human. So our types plus instructions for Claude. And again, another 10 to 15 minutes, sometimes a minute. Just, again, small commits, very frequent. That's what we're looking for. Okay, so we got our types. Let's find a way to safely parse this. And so I'm going to create some JSON, and I want to find a way to parse this out. So we've got some humans, we've got some types. What we're going to expect is that this kind of JSON is going to come from a Dynamo database, unstructured data, but it could also come from a local machine, local text file that's JSON. And we want a safe way to get this data. We don't know how we're going to expose an API yet, but that's okay. But we do know at some point we're going to. We don't know the mechanics behind it, but we do know how to parse JSON with JSON parse. And we do know how to do it safely using the result object from Neverthrow. But we're not sure if Claude does. So let's describe those requirements. So I'm going to do describe, and we're going to say safe parse people. And it is synchronous. Okay, it should parse some people from some JSON in a happy path. So this is a happy path, and we're going to create some people JSON, and we're going to assume it's isomorphic, which means that if we have a person type, that we should be able to convert this to JSON. So we're going to say person A is a person, and we're going to import that type automatically. Nice. And so we're going to create one called first name. Ray, that's me. Waran, that's me. And species is human. Why did I code hint dog when I said human? Clearly said human. Person B is Her Majesty, which is first name Ray, and last name Fortran. Species human. There we go. Okay. Then we have a people list. We're creating a big old people list here. And TypeScript's pretty good at inferencing. It's actually pretty good nowadays, but we're going to be strict. We're going to say it's an array of persons. And it equals person A and person B. And it doesn't like people B. It's person B. Person B. You could tell by the faded out text it was good job. Okay. Then we're going to get a result. If you're not familiar with the result type, it's very similar to a promise. Two key differences we'll talk about in depth. Number one, it's synchronous. It can be asynchronous. For now, a result is synchronous. Result async is asynchronous. So they both have the ability to return a box. Promise is a box. You have to go .then to get the data out of it. In a result, you have to do the same thing. You have to either A, safely match out of it, or B, do an unsafe. You're only allowed to use unsafe in unit test. It's very similar to the result type in Rust. However, unlike a promise, you get a type for the error. And if you're familiar with effect, that should be a very familiar thing. If you're not, if you are familiar with discriminated unions, you should understand that there's different things that can go wrong. Reading a file, you could not have permission. The file doesn't exist. The file is empty. The file is the wrong format, right? Individual different errors. They're all errors, but different types. Allow you to log differently, maybe try something different. So results is going to be a result type of person with arrays, or for now, we'll just make it an error, normal JavaScript error. And we're going to say safe parse people. And we're going to convert this people to string grapon. So people grapon. And we'll do JSON stringify people. So if I give you this people grapon, this should be a result of people. But first things first, let's assert that the result is okay. That's a way to determine if it's an okay type or if it's an error type. Very similar to a promise. If you want to say, is this promise a .then and we're good, or is it a .catch and it explodes? Which kind of promise is it? If you ever use RxJS, it's either an observable with your type, or it's observable with never in it. That's an error. So I'm going to say to be true. Okay, so it doesn't know what result is, so we're going to quick fix and import for never. It doesn't know what safe parse people is because it doesn't exist. So we're at a point in the regular refactor where we're waiting to implement the actual. We've got all our types set up. Our test is good. It's spelled correctly. We've got the right types. We've got the expectation. But the function doesn't exist. Normally, I would go implement this function, but we're going to get the AI to do it. So Claude, implement this failing test. Claude is going to go implement the failing test, but first, it's going to identify the steps that it needs to take to get there. It's going to read the failing test to understand requirements, implement the never throw result types. Good job. Implement the safe parse function. Good job. And add to the exports of test import. Fantastic. So we're going to let it do the work that I normally would do myself. First, import result, okay, and error. Good job. It's going to have to do it very imperatively. This is good. Dig it. I'm code reviewing in real time. We could totally do trunk-based development with AI. We wouldn't have to do PRs because I'm reviewing it in real time. This is, if you're not familiar with why trunk-based development works, imagine the AI was a real person. We were reviewing this code in real time. We check it in the trunk. It doesn't need a peer review because we peer reviewed in real time. Make sense? Except I'm doing it with AI. Okay. Safe parse people. Let's take a look at this. Takes in a JSON string. Looks good so far. Returns person or error. Looks good so far. It wraps JSON parse into try catch. Very good. If it works, we do a Zod schema to person schema. And then do safe parse, which is good. The name sucks, but that's okay. Because is it results or the safe parse results? Right. I would normally destructure it, but that's okay. We'll do that in refactoring phase. And if it's a success, it returns okay. If it's false, it returns a validation error message as to why. It also is assuming that the error is an error type, which is not always true, but in Zod's case, it is. Otherwise, we have some unknown error, and assuming it's an error, it's going to give a message, otherwise an unknown. So a lot of code here. It really didn't need to do all this. What it could have done is just returned an empty array to make the test pass. It really didn't implement all this stuff. So good and bad. Obviously, I'm excited because it pretty much implemented almost exactly how I would do it. These changes are legit, but this is an example of where the AI is not following the green step correctly. So we're going to iterate on the green step. Again, I'm excited it's smart. I'm excited it wants to go. But I would tell the AI the same thing I'm going to tell a junior, and that is you did the green step wrong. I don't care if your IQ is 160. You're working in too large of batches, and you're trying to solve too much too soon. Yes, I'll take it. But we've got to go iterate on this Claude MD file because it's doing way too much. All right, so it's importing the function. That's good. That'll make the test pass. So now it's red. It's going to go to green, super green. Oh, 2 test pass. Good to go. Funky Commandline. Well done, Claude. Well done. Not bad for your first time. Nope, we're good. Notice the last step is the second time I've had to do that. It wants to run the test after it wrote code. The tests are always running. So we're going to change two workflow things. First, it did a good job. Our test now returns the persons the way we want them. However, it's not quite right. So let's check that in. That's good. Safe parts of people. Rock on. See how small this is? Small. Working in, 5 to 15 minute batches. So let's fix that right now. Rightnow.com. Claude MD. Okay, let's talk about TypeScript, creating types, Zod. Test-driven development. When writing code, you do not need to run npm run test when complete. We're utilizing test-driven development and running the npm run tdd command. This runs Vitest in watch mode. Thus, the tests are always running. That should fix the asking to run npm test at the end. However, let's talk about the next thing. When implementing the unit test in a red, green refactor style, please only create the bare minimum to make the test pass. And rather than having to give an example, we can literally take the example that it did for us. And so it kind of learns from what it did wrong. We don't have to create these ourselves, because the biggest challenge when doing programming tutorials is not necessarily just finding good examples. Sometimes it's also finding good, bad examples, things that are wrong. This is a perfect example. For example, in the green step, you're supposed to do the minimum amount of code to make the test and types, test pass and the types to compile. For a test, a unit test, that looks like this. Shift, copy, undo. Copy pasta coding, clearly different than vibe coding. Is it copy pasta vibe coding? I don't think so. Vibe coding is conversational. This isn't a conversation. This is augmentation. All right, so it should parse some people from JSON, blah, blah, blah. That test should only, and I'm going to do, maybe I should do bold, capitalize. Let's do this. Let's emphasize. Only implement this to get it to the green step. And we'll capitalize green. The green step. TypeScript. Once again, copy pasta vibe coding. It's not vibe coding, Jesse. Stop saying that. All right, so the only way to make this pass, like without all this stupid crap, is literally return okay, empty array. Done. That will make it pass. That's safe enough for the types because it's an okay, so it's a result. With an array of people, it's an empty array. You don't have to create people in it if you don't want to. If you wanted to, you could put a person in there just to make sure the types are there. So first name, Wi-Fi. Last name, Borden. Species, human. Cool. And that would get you like the basics of the test. Then we could show the example that's bad and say, this should only put step. This is a good example of that. This example is bad. While it does pass the test and ensure the types are legit and compile, it is too much too soon. And this is a unavoidable superpower of LLMs. They want to do too much too soon, and sometimes they influence you in a wrong direction, or they do too much. And even if we believe they're on the correct path, it's still not the correct way to do it. So too much too soon. TypeScript, copy pasta. Good job. Save. Okay. So let's delete this for now. We'll keep it on our clipboard and we'll put it in the Scratch file. And Claude, do you understand my updated instructions for TDD? Two things. A, don't need to run npm test. We're always running npm test. We're using Vitest in watch mode. Number two, you need to implement the smallest amount to get the test to pass in the green scenario after red. You don't need to implement everything. So let's see if it understands. I understand your TDD instructions. So talking about a pirate, so I know it reads my file. You want to follow regular refactor cycles. Good. Absolute minimum. Good job. That was bolded. I like that. No run npm test because you're already doing that. It's fantastic. I should return the full thing. So it's cheating, but let's see if we can do it again. Yes, sir. I make it so. Okay. Now I'm talking like a pirate to my AI. This is problematic. So step one, import the OK. That's good. Notice it's removing the ER. It knows what's fixing to happen. It's thinking 2 steps ahead. This time it's actually okay to think ahead because it knows to do the import to make it pass because it doesn't want to use unused imports. Good job, Claude AI. Now that is the bare minimum to get it to the green phase. Love it. Good job. So much better. Hopefully it repeats this behavior in the future. And again, once I have this Claude MD file, I can use it for every project. I only have to build this thing once. You'll notice that there's a trend right now for a lot of people who are posting their GitHub instructions MD for like ChatGPT and Gemini, Claude MD for Claude. So good thing happening. Okay. So we're going to hit save. This is good. We're going to commit both. We've got our bare implementation for instructions and we got our bare implementation for the test. That's good. So updated instructions, bare minimum for green, push. Okay, massive amounts of project. Massive amounts of progress. All right, so let's do the code review again. So I'm going to take this in here because I like this implementation, but I don't like some of the things about it. So I'm not going to save it. I'm going to replace it, hit save, and the test should still say green. Good job. So that one was like a really quick refactoring step, right? We made the code better, it handled other things. The problem is wrote a failing implementation before the failing test. And you notice how we checked in code that didn't pass, right? We checked in code that wasn't compiling. So let's go ahead and import that. And we got za, that's good. And imported the error. Okay, good. So let's undo that real quick. Let's write the failing test. We'll say it should fail to parse bad Raycon in on unhappy path. So you notice that time it wasn't the AI who got excited and did too much too soon. It was Jesse Warden, the coder. So me and the AI treating each other with reasonable expectations. So let's do copy pasta coding for the win. And we'll stringify a cow. It's not bad JSON, it's cow JSON. Bad cow. Raycon. Cows are good. Just FYI. Okay. Let's see if that is good enough. So that should be an is-er. Now we're going to hit save and it'll fail because the implementation around it doesn't exist. That's good. So now in the red phase, that should fail. We expected it to fail and that's good. So let's get it to the green step. Implement the failing test. So now it's going to refactor code. So although it's doing regular refactor, we've already got a test with the minimum amount to pass. So let's see if it can update the safe parse people function to match both the types and the behavior or how it works as well. So it's going to import error. Very good. I like it. Love what you're doing. Taking way too long, but you're working. Cool. If JSON string is cow, okay, not quite what we were looking for. That's okay. Sure, keep going. Whatever. This is awful. This is where I would tell the junior, you rock. You took me a little too literal to get it to the green style. Pure DD style, just to get it to the green. Is this my fault? Is this the AI's fault? Who knows? Okay. So let's iterate yet again. So we're going to take this. We're going to Claude MD. So let's check that in real quick because it's hilarious. Because again, we are green. We still should refactor. Green, LOL. LOL. Cool. So, Claude, we need to talk again. However, keep in mind, once the test passes, you can continue to refactor the function to implement additional tests. For example, if we add an unhappy path test to the above, that may look something like this. TypeScript, copy, pasta, coding, shift, copy, tab, copy, pasta. To get the code to a green stage, yes, the following would technically be true. TypeScript, copy, pasta, coding. However, what we're looking for is the behavior of the failing test, not checking an explicit string. The behavior is bad JSON causing JSON parse to fail. That's the behavior we're attempting to test here in the unhappy path. A better implementation would look like. Now, again, this is getting very explicit on implementation for this particular test, but the idea is that this would apply to other examples where you're parsing, doing JSON, error path scenarios, things like that. So what we're really looking for is try catch at a bare minimum, result const, result. Again, we're doing the bare minimum to get this to pass, right? JSON parse, JSON string. And then we're going to return the success data error of, how did they do it before? I think it was something like people, C, array, person schema. And then we should probably make a better schema for that. Let's do that real quick. ADHD brain, got to do it before I forget. People schema. Z, array, person schema. Export, type, people. Z, infer, type of, people schema. Okay, I like that. Why are you mad, bro? Oh, because I forgot to. Got it. So, save that real quick. We're just updating the type. Shouldn't affect the compilation or the test. Okay, that would be more for person schema. So we'll do this, people schema, safe parse. Take in the JSON string. There we go. So we got a safe JSON parse. We got a safe person schema for the JSON. If success, then return OK of the data. Otherwise, return of the error. We'll just say new error. And we'll just ignore the error for now. And then for here, for the catch, we'll do the same thing. Return new error. Right? That's like the bare minimum that you could possibly do to get this passed. Save. Okay. So let's undo this. And let's see, using our new instructions, if it can do it. Implement the failing test. Let's see if it can read those instructions and kind of do like the basics. Again, we've updated our people schema, so it should be able to, not get rid of that intermediary unsafe step for Zod schema parsing. So that's something that I, as the programmer, identified. However, we still need to give it instructions to like refactor more, so don't be too explicit. So a little more freedom. Okay, so it's going to do try catch success. That looks good. But it made more errors explicit. I like that. I like where it's going, but it's just enough to make the test pass, but not too much to like create union types and distributed unions and all the other craps. That's good. I like that. That's good. Cool. So our test pass, that's good. And we've refactored to handle the happy and unhappy path, but it's just enough refactoring to make it good. I like that. That's good. Okay. Updated instructions for refactoring and unhappy path again. .com. We are rolling, folks. Rolling. Okay, so we got a safe parse JSON. This is good. We have the ability to parse JSON. We have schemas for it. We have types for it. Let's do our ability to read and write to disk. Let's start with the low-level implementation details. Let's see if we can read a file from disk that gives us string JSON back. And we're going to abstract away all the low-level details of file. So that's kind of like as high as we're going to go. So we'll say read people. And I'm going to say from disk. Yeah, disk. Yeah, that's good. Unfortunately, because of implementation details, this is often async, but I'm going to force it to be sync. So we're going to say it should read from disk. Read what? It should read people JSON from disk in a happy path.com. So that's good. That's good.com. And the result, and it's actually well, I want it to be sync. Yeah, I don't really care. Well, should it be async? I think it should be async. Because I'm curious, if we made it async, it might make it easier for other people to make adapters. So for example, if I made it sync, how are you going to do sync with DynamoDB? You know what I mean? Like that's a REST API call. So if we do it with async, it might be easier for the future implementations for everybody async. So I think it's a good idea. So we'll do that. This will be our first use of the result async as well. So let's see if it figures it out. And actually, let's be proactive. I know that Claude may struggle with this. So let's talk about error handling. So we've done some TDD stuff here. We've done some Zod. Let's talk about other types. We've done Zod. Let's do result type. Errors. Functions that can fail. When functions can fail, typically, you'd either allow the exception to happen or throw an error if it was intentional. An example would be this function throws an error if the name does not equal Wi-Fi. And we'll do TypeScript. So I'm creating an example for Claude, but I'll do the same thing at the nth degree for a junior to illustrate the concept. Sometimes I create multiple examples, but I think sometimes getting the core fundamentals really helps because it's applicable to everything. The challenge is that it's not applied to the code in place. So we're going to have to do multiple examples to kind of ramp up how close we're getting from concept to actual engineering implementation. So let's do 2 for now and see how it goes. So we'll say a function of is name string. And we'll say a Boolean, right? But these are the types that lie. So we'll say if name equals return true, else throw new error. Not, we'll say error, not rabbi. The problem with this function is, this function has 3 problems. Number 1, there is no type-safe way in TypeScript to type the error. Our goal is to write as type-safe code as possible. Notice how I spell type-safe differently. Number 2, this function requires, this function's types lie. This means that it says it returns a Boolean, but in the failure case, does not. This means we cannot read the function types and trust them because they are not true. This in turn makes them not type safe. Number 3, developers have to read the code to know how it works. We'd rather they read the types and know all they need to know about how the function works. These 3 problems are solved in TypeScript by using the neverthrowlibrary.com. It implements a result TE type for errors in synchronous code and a result async TE type for asynchronous errors. AGA promise result TE. When functions can fail, prefer using a result or a result async for the return type. Cool. That's really good. Okay. Let's see if we can handle it. So the result is going to be a result async, but when we call await, you can await on a result async because it's basically a promise with a result in it. And so we should get a result out. So that result is okay. And we're going to say read people from disk. And we're going to give it, for now, file path. So we'll say people.json. And we're going to give it some kind of stub. So we're going to say stub fs, I think, is a good stub file system. And we're going to expect result is okay to be true. And so the stub fs is going to abstract away fs. So we're going to say stub fs, and we're going to kind of emulate the file system fs. Now, I can't remember. Now, normally I'd Google that and I'd read it, but let's give, before I read too much of this, let's give Claude a chance. Can you give me an example of Node.js reading a file via fs read file? Let's see if Claude can give us an example. And then I know how these work, so I'm 90% confident I can identify hallucinations. So let's see. OMG, it's already given it to me in a style I want. All right, so file, read file, give it a path, the encoding, and you give it a callback. Promise style, you do it from FS, and then with Neverflow, following your guidelines. That's good. Okay, so not only is it giving me an example, but it's giving me in a context that I want. This is gorgeous, gorgeous. Cool. So I like this. Let's see if we can implement it that way. Okay. So read people from disk, and if I were to implement this in its style, it's going to do an FS promise. So we're going to say that with a read file that takes in a file path. I'm doing a prefix because it's not used. in the stub and encoding, which is not used as a string. And it's going to give back a promise. Notice I'm writing in JavaScript style. Resolve with some kind of JSON. We're going to stringify it ahead of time. That is our person. So we're going to go an array with a first name, rapper, last name, pardon, and a species of human. Cool. So that should give us a good stub. It's reading a file in a promise style. Did I spell it right? Read file, file path UTF-8. Okay. And it gives back that. Okay. I think that's good. So let's see what it does. If I hit save, we're in the red step, and it's at the point where everything's good except for it can't find the read people from disks thing. So that's good. So notice how when you're asking Claude questions, it's already reading my context file, configuration file for Claude MD, but it's putting it in a context that I've already wanted. So it's already speaking to me in the way I want to be spoken to. I don't mean like language like pirate. I mean in the style of coding that I do, functional programming with result types, right? That are very type safe. So let's go ahead and implement the failing test. And it should do it. Let's see if it does the minimum implementation, if it goes too far or it goes kind of weirdly in the middle. Let's see. We've got it, enough context now where it knows how to type. It knows how to do result types in a type safe way. And it knows how to do the minimum amount of TDD, but enough where it should be allowed to refactor. So let's see. Imports result async. That's a good first step. I don't know where it's going to use it, but we'll find out. We'll find out. Was it up here? Oh, yes, it was. Okay, cool. That makes sense. Okay, it's exporting the minimum to get it to pass. I like that. Okay, and it's not using the FS right now, and it's any. That's fine. Notice I'm actually anti-any, but that's actually okay. So let's that's a really good thing. I'm getting excited again. So like if I saw a junior do that, I would like be able to talk to him for 2 hours. So I get excited like teaching Claude this because then if the model gets better, it would know how to do this in the future, and I wouldn't have to ever do this again. All right, so let me review the code it wants to do. Import. Okay, that sounds good. That's good. What else are you doing, buddy? You're importing the code. The test passed. Okay, that's good. So it did the bare minimum. That's great. I like it. Let's go back to Claude MD, and I'm going to check this in. So this is a work in progress to get the minimum amount to pass for FS. This is good. That is the red phase. We're going to refactor here in a minute. Let's go back to types for TypeScript. And let's fix some things. So types, creating types. Let's talk about unknown types. When you don't know enough information about a type, you may any. However, we want to avoid first the tsconfig JSON, I don't know how to spell it, has strict mode enabled. This should be preventing the use of any. More importantly, though, we want our code to be type safe. A better type to use is unknown. If, however, we have to cast the types, cast or convert the types, and we're not using Zod, then unknown may not work. If that's the case, and you find yourself reaching for any or unknown, stop. Let's talk about it. We'll find a way together to make the types work. Cool. So I don't want to use it anymore. Let's go back and look at the return type. So it's a promise result person error. Okay. This is another problem, is that this technically should be an async return. I think because they did async, they did that. So let me test this myself just to confirm. So I'm pretty sure you can go result async. and then take out this, and then take out this, error async. And then, is it mad? Why is it mad? Did I do the person wrong? Dismiss the volume of error. Oh, I'm sorry. I'm a dumbass. Async. Okay. So, yeah, that's a better type. So let's talk about this too. When returning asynchronous values, you may think you can utilize something like, well, that's fine. We should be more explicit and utilize the result async type instead. So the above example would be result async. And you only need one bracket instead. Okay, I'm not going to get it to fix it, but I am going to check those things in. So this is good. This is good. Tester passing. We can refactor our heart's content. So we'll say updated instructions around types and choice and result async plus a whip for read JSON. All right. Again, 15 minutes, small changes, small batches, small increments, iterating on our context file to get Claude to code the way we want to code, being uber explicit, but then expanding on context if it's taking us too literally, right? Okay, so that's good. Let's do the unhappy path and see how much of that it does. So let's do it should fail to read people JSON from disk in an unhappy path when the JSON is formatted. All right, let's say JSON fails to parse. That's better because then we can indicate like the JSON parse itself failed. We're not really concerned about Zod at this point. Cool. So that should be async. And let's do copy pasta coding. Whoa, scroll up, homie. Copy pasta coding for the win. And we're going to tab. And then from here, we have people JSON, but this one is going to reject us. Reject. I don't know if we should do JSON. This has nothing to do with JSON. This is should read people. My bad. Should fail to read people JSON from JSON disk in an unhappy path when the file fails to read. Yeah, much better. Okay. New error. Failed to read file. Okay. And we'll put a unit test in there in case we test this later. And we're like, what is this? Okay. So this is a stub unhappy fs. So we're going to be explicit here. And that should fail. So we'll say is error to be true. All right. Now we got our failing test. Good. Claude, implement the failing test. We have so much amazing context and clear directions with the ability to expound, recognizing the values of different types and libraries and expectations. Let's see what she can do. Okay. So she converted to result async with a file read pass. So now we're doing a real implementation here. However, it's doing a basic error. Ooh, a string injection. I'm going to take that. This isn't going to encode correctly because we can't guarantee the type, but that's okay. And oh, look, unknown, baby. Good stuff. Ooh, and it did in chain already. And then, no indent. Actually, indent in this case is pretty good. Gets the file contents as a string, and it parses people, and it gets it there. So normally, I would say do the unhappy path, but notice how it did two things here that I'm actually happy about. So it did the unhappy path and happy path, but it did implement the safe parse people, right? It knows that once we do the happy and unhappy, that's usually when I start refactoring towards the real, and it did the same thing. So I'm actually cool with this. There's a lot of things I would improve, but I like where it's going. And the fact that it did from promise instead of safe promise or, throwable, this is good, dude. I liked it. I don't know if this is 100% type safe, but that's okay. This is great. This is great. I love it. Okay, so notice how the test is passing, but we're getting some compilation. So this is where you can spot with types that the AI thought it was on our track, and so did I. But then TypeScript's like, hold on. So now we have TypeScript watching our back, unit test watching our back, I'm watching our back, and the AI is watching our back. If you're one of those crazy people who opens Cursor, you can have Gemini 2.5 watch our back, right? But the point is, we got 4 avenues of quality checking here. So let's see here. What's wrong with it? Result unknown is not type of. Ooh, yeah, because it doesn't know. Read file, I think, is going to be an unknown. That's, yeah, okay. Interesting. So this would be what exactly? This is interesting. The unknown is unassignable type. Okay. Normally, I'd fix this and investigate. Let's see how good Claude is. It kind of misses. Claude code passes the test, but the types are wrong. TypeScript is showing compiler errors. Can you fix? Now, maybe it can, maybe it can't, but I'm interested because normally, again, I would just dive in. Sometimes I would extract smaller functions. So even more extreme Chicago mode where like you just do parse like read file and it just does a read file function, but you do it with the types to help TypeScript. Okay. Oh, this is also awesome. So I think the as keyword is really, really bad because people, or in this case, AI, is telling TypeScript that it knows better. If it does, it wouldn't have written the bad types to begin with. And I would have been able to quickly fix it. So it's getting away with this because we know that the read file probably is a string. And that's why it's, doing this. Normally I would say don't ever, ever, ever use the as. But I know it's doing this to compile. So we're gonna allow this, and I'll tell you why. 2 things we got to do. First, we got to tell Claude to never use as. Remember how we said never use any? Second, we're going to go do some type narrowing on our own, right? Like printing the type out in logs and use that to validate if we're on the mostly happy path. So our tests are passing, so we can play around here. So again, just because it says string doesn't mean it's actually a string, right? TypeScript is not runtime enforced. So we're going to see our file contents, and then we're going to actually see what the type of is. So if I go look for file contents in there, so we're going to get our JSON back, and it's a string. So that casting is actually okay, but what we should do is the more correct way, and I'm going to refactor this to be more type. So we're going to say file contents is an unknown, and we're going to say if type of file contents is a string, then that's a way to type narrow for TypeScript. Else, we're going to return error async, new error, file contents, and we're going to do string injection so we can help ourselves with some kind of useful error. File contents is not a string. Type of is, and we're going to go type of file contents. And so that'll inject whatever the type is in there, maybe object, undefined, something. But now it's a little more type safe, and we don't use promise as string. So we're going to take that out. We don't like typecasting like that. It's very dangerous. So that's good. So we hit save. Things still pass, still green. So we're refactoring our heart's content. Change that to unknown. We need to change. Here, let me change that to any real quick. We need to change the fs any to an actual file, or I'm sorry, node file system type. Can you fix? Now, normally I wouldn't know if the AI is hallucinating, but TypeScript has our back. TypeScript can tell us, no, that is the incorrect type. If it's even really bizarre, then we can go use Google and research. But I'm very curious based on, Claude, in this case, Sonnet being recent, it should know. So promises as fs from sf. Okay, so far so good. So it's actually casting type. It's fine. Is that it? Is that all it's doing? There we go. That's what I was looking for. Type of sf. Good, good. Okay, I like that. Let's see. All right, let's see if TypeScript likes it. It does, but now our unit tests aren't compiling. Interesting. It's probably because my stub is not 100%. Yeah, that's good. Go ahead and replace file path. That's good. I like that. A lot more type safe. That's good. Okay, so tests are passing, but the types are wrong. That's good, but now the unit tests have compiler errors. Can you fix those too? So sometimes you'll notice that Claude will fix both, but like things like this, it just didn't notice. And again, the red squiggles is so you can identify it as well. So even though Claude, in theory, ChatGPT, Gemini, and others, they can spot many files at once, it didn't notice these for some reason. So it's importing that. That's good. I think it's going to change the casting on the stubs. Let's see if it actually does it. I'm pretty sure it will. Yeah, it's casting it and then casting it again. Okay. Yeah, that's fine. That's good. That's good enough. We're just trying to implement the interface, and a lot of these Node class-based things make it really hard to stub them. So this is reducing type safety a little bit, but it's good enough for now. We can refactor later. This is good. Pragmatic, not perfect, but good. Okay, good job. So now we've got implementation of the types for the unit test. We've got the unhappy path, so it's more type safe, and it has an unhappy path. We've done more of a real implementation. We've made it more type safe using unknown, and we've typed specifically the file system itself, so we don't have any anymore. So this is really good. You'll notice that we could build some of this into the Claude MD, but because it has code now, Claude is going to have context. So some of that in the prompt isn't really needed because this style of code, it'll be able to read. Unhappy path for reading file. So this is good. I dig it. Let me give an example of what I've seen some of the TDDers do. I don't agree with this, and I understand the temptation, but I want to show you how to do it, just so when I talk about it, you go know what I'm talking about. You see how we did a single test for a single happy path, and we kind of iterated on that, and then we kind of like refactored it, and then also improved the types at the same time. So what I've seen some of the TDDers do that get impressed with some of the more mature models, like Claude, for example, is they'll do all the tests, very similar to like Kent Beck's original. Like he'll think of all the tests he wants to do and write them down, and then iterate each through those. Some people have taken that to the nth degree where they write all the tests and they go implement it. And it kind of defeats the small increments. The reason I think it's okay is because A, the test pass, B, the types pass, so they get a massive amount of confidence. Plus, they've reviewed the code, so it should be good, right? In theory, yes, but again, they didn't read and write the code, so their comprehension, based on the MIT study around ChatGPT and based around the fonts of like Arial versus Comic Sans reading, that reading comprehension is gone. So how much of that are they not understanding? Is it good enough because they read the types and it matches and it works and they understand the requirements? And if they're following the Chicago method, that it should be okay? I have no idea. I have no idea. So we're going to do the opposite. We're going to write people to disk, but we're not going to do any of the review of the code. We're going to vibe code it. And again, we're going to vibe code it from a TDE perspective. We are writing the test, but the AI is going to do all the implementation. People to disk. It should write people to people. Let's say people JSON. People JSON string to disk in a happy path. And this is going to be async because it's just using the same FS promises. Node file system at your service, ready to read and write.com. So result should be an await of write people to disk. And it should take, what is the string we were getting? It's people JSON. And we're going to do some JSON strings again. So we're going to copy pasta coding for the win. Anybody want to dry their unit tests? I'm not going to dry these, but I'll show you if you can get AI to do it for you. Because that's the boring stuff, right? Remember when dry used to be fun? It is for some people. Okay, so we got people JSON, and it's stringified. So we're going to write that, and we're going to pass in a stub FS to write. So we're going to copy pasta coding, copy pasta type safe coding. So here's our fixture data. Here's our stub, but this one's going to write a file. How do you write to disk using FS in Node. So it's going to do the same thing it did before. Give it to me in result async style. I bet you. I bet you. It's trying to change my code for me. That's hilarious. You don't need to do that. There we go. Okay. So write file with a file path, content, and then encoding. I literally forgot what I just read. All this talk, Jesse, about reading comprehension. You read stuff, you forget it. Good job. Write file. Takes file path, content. Lowercase string, bro. Learn how to type. Encoding. This could be any, right? I don't know what this is. Let's ask real quick. What is the return type of FS write file? You should know, Claude. You're smart. And I gave you bunches of tokens to figure that out. Please justify your use case. Promise void. Yep. An object-oriented programmer wrote this. God forbid they send anything from a side effect. Okay, promise.void. Got it. So it returns nothing. So we'll be explicit and say undefined to match the type signature. Okay, I think this is good enough. Let's see if it can implement it. But before we do, we're going to violate the small batch and we're going to do a big batch. So we're going to say it should fail. I'm going to copy this whole thing so I can get wordage exactly. It should fail to write people JSON to disk in an unhappy path. And we're going to have a stub fail. So let's copy pasta coding for the win here. And I don't really need that much of a stub. We'll just say the fixture is like, I don't know, JSON stringify an array, right? It's just an empty array. So that'll work as a stub. Because we're not really interested in the data per se. We're really interested, like, did you fail to write it? Now this is going to be a promise reject, new error, unit test, failed to write. Expect result is error to be true. And up here is expect result is okay to be true. And let's think, what else could fail? The file path couldn't exist. The content doesn't exist. But as long as the types match up, I think we're good. So this is the only two happy paths. So notice I did the happy and unhappy path. So let's say implement the failing tests. And so those two tests fail. It's getting like TypeScript problems because I think I have a compilation error because I'm stupid. Oh yeah, we have two. My bad. My bad. Yeah, so it's going to fix my test because I'm just tired. So it's right. That looks good. It formatted it correctly. I'm down with that. It wrote this with the unhappy stub and the fixture. That's correct. For the error, that's good. Okay, yeah, I'm good with that change. Fix my test first. Good job. It's fixing the types. Love it. Good job. So I see the squiggles, but it's still working. No big deal. So now we got two failed tests. That's good. So now we're in a good red state. And it's not defined. So everything's compiling. So now it's going to do result async from prompt write file, or it's going to return an error back. I think that's great. And notice that return sync is void. So it just comes back as an okay. So it's better than nothing because we at least get an okay back. So that's good. Dig it. So once it saves it and saves the test and imports it, then we should have both tests going to green if it's smart. There we go. So we did a red-green refactor. Well, really it's red-green. We didn't really refactor yet. But notice that it's passing. And so this is why, the vibe coders and some of the TDDers are like, wait a minute. It already fixed our test. It actually knew the test better. What if we get it to write the test? What if we write all the tests and just let it implement it? So that whole crew over there of like, let the AI write the test or just write a bunch of tests and let it implement it. It kind of violates small batch dev, but if it works, right? And so like, I'm not going to fix the types yet, but take a look. So see how it's like a lot bigger batch? The file implement is a terse, implementation, but you know what I'm saying? Like there's a lot more code here in this batch. Not a lot, like in terms of like what we've been doing. Let's say fix the types in the test. So reviewing this code, this is something that I might allow to pass, and I can see the temptation. I still would rather want to do the happy path first, make sure we feel good. But it's doing FS. Let's see what else it's going to. Still thinking. Okay, that's hilarious. That's hilarious. I don't really like that type. It's doing a pick, really? A pick. This is where AI goes off the rails. So notice how I'm trying to get it to work, right? And it's like doing pick and it's doing type of and all this stuff. So like now the batch is getting bigger and bigger. So we got the test, but now we're like trying to fix the types. So let's go look at this commit now. Yeah, it's fine. It's using a lot of tokens there. Okay, so let's go look. The test pass, the types still aren't right. And now it's got like all this insanity. Doing a pick of read file and saying I implemented the function correctly, which is clever, right? Instead of implementing the entire class, you only have to do one function. Assume scope still stays intact because you're at runtime going to give it a concrete implementation of FF's promises. So all the this inside would still work, but the type is only interested in the right file. So it's using pick to say just get the right file off of that class. That's all we're concerned about. If we had an object with that, would that match the types? Yes. So that's an example of, large batch. Write large batch. So again, I don't recommend that. I don't like that. I think it's doing too much too soon, too much code to review. If it goes in the wrong direction, too much to read and back up, but I understand. Okay, so last thing to do, let's take a look at this little thing right here. So you'll notice that it's using the old school function syntax. We should prefer arrow functions. So that's a syntax thing. So let me copy paste this. This is a great example. This is going to be one of the last implementations of Claude. So let's go to Claude. Let's go to the TypeScript. Is there TypeScript? TypeScript. There we go. Creating types, unknown types. Say type casting and type narrowing. When writing types, avoid using the as much as possible. It is dangerous and can turn off critical type safe features. If you feel like you need as, stop and let's talk about it to see if we can figure out how to cast it correctly. Styles in here. Code, we'll make this a important one. Code style. For TypeScript and JavaScript, we should prefer arrow functions over old school function syntax. And actually, it's not old school functions, old school named function syntax. We should also avoid anonymous functions. For example, here is a function that does two style things incorrectly. TypeScript. First, it's using function write people to disk when it should instead be write people to disk. Let's do the type signature. When it should be using, instead of export, that's fine. Const write people to disk, and then the type signature should be with a fat arrow function. Here, we're going to do the same thing. Here. Okay. Those match. Second, you'll notice the arrow function, or notice the function is using the return keyword. While arrow functions, make that code to be explicit, while arrow functions support the return key, we should endeavor to create expressions. They are more pure function-esque, compose easier, prevent the use of temporary variables, and thus imperative coding styles, which we should avoid. It's okay to do them in unit tests when we're just trying to get to the green step, but we should still try. Perhaps when refactoring with a capital R or code review. And this is key later. An example would be, again, that above function. We could rewrite in our preferred style like this. Script, and we'll make sure TypeScript is spelled correctly by copy pasta coding. And we'll say const, write people to function, equals this with a fat arrow function, but we'll take out the return keyword and take out the bracket. Voila. Okay, so we got the style and we got the lack of as keyword. So now let's do a code review. So I'm going to say what I know before I'm biased by the AI. So let's take a look at just the code and start from the top. So first thing I notice is that none of my types are used. And so this is a perfect example of Yagni. You can accidentally in type-driven development go too far. Very similar to type TDD, where you work in small batches. You can work in large batches. Types, to me, a lot harder to work in small batches with types because you're actually using that as a language to define your business space. Sometimes it's important to get those thoughts written out. You're writing, and so it's hard because sometimes those types are not really helpful. The second problem that I have with it is that for some things, the language is subjective. So, for example, I prefer type instead of interface, right? The issue is that interface implies a class, or in my case, an object, right? And objects, especially from third parties, are better as an interface because they can be extended and changed, and they often are, right? So this usually, to me, implies something outside of my code base, which I kind of like, using that for. And then the last thing is that you notice how it's all kind of faded. It's because we're not using it. And so this is an example of like we wrote code that the test didn't use. And usually test-driven development prevents that. But type-driven development is kind of in this weird space ahead of the test where you're kind of defining your problem space and really defining the contract. So you're doing domain language, like domain being the problem, like what business problem you're solving, right? Our case, it's dealing with people. It's dealing with persons. It's dealing with species like human and dogs. That's the language. And so having those in types is great because we have the same language for everything. The programmers can speak the same language as the product owner and the business people and the users, but it's not being used, right? So that's one thing that's concerning. The second is as keyword. It's dangerous. So you should look at it. Doesn't mean it's all bad, but you should definitely look at it and go, wait a minute. It's not a red squiggle, but it could be a runtime exception, which is even worse, right? So you want to look at that. Again, like the function, syntax, it's fine. It's not our style, but linters can usually fix those nowadays. So you don't even need to talk about it. But with AI, you do. And with junior developers, you do. Again, we're teaching the AI with our context file to help it learn. With juniors, we're teaching them and they actually grow and learn. The hope is that some of these files could be reused in reward models where you could refine it. And so the reward models, as long as you don't punish them, you can say, this is what we're looking for. Right? So they don't try to like lie about not telling you that they hack something. So same style, right? So we're reviewing that. So that would be a comment I'd put in a PR. So this error is okay, but I want to know exactly what went wrong. Did JSON parse fail or did Zod fail? So the JSON looks good, but our contract has changed. Is that what's going on? Or the JSON was not the JSON we thought about? Like it's important to differentiate. So you would say like a JSON error versus a Zod schema error, right? Like we want to know the difference between those two. Now, sometimes you can't handle that from a runtime exception perspective, but from a logging perspective, it is super important. Help you debug better. So I would definitely make that a comment for refactoring. So the code doesn't need to be changed; just make some errors so the test still passed. Let's see what else. Yeah, here that needs to be cast as unknown, and you need to handle the fact that it might be not an error. Let's see what else. Same thing for error here. This is all good. This needs to be a custom error, so we know it was file system that failed, not the actual ZOD that failed. Differentiate between two types of errors. As you compose all this code together, you would have the JSON error, the ZOD schema error from there, the read people ZOD schema error, the ZOD people JSON error. So you now have 4 possible errors that could happen, right, in your code base. Differentiate between the two, whether using Splunk or Datadog or New Relic. Those errors could be mapped very safely to errors that you could see. So we definitely want to have explicit things for that. So we have a type safe way to validate, are we actually doing metrics and are we actually logging? So the TypeScript can help with that. We don't have to write unit tests for our logs. You should, but we don't have to, as long as we got the types for it. More importantly, we know if we send it because it's embedded in the type, so we don't have to assert it. If somebody breaks it later and we wonder why our dashboards breaks, because you can look at the compiler. So that's also helpful. And yeah, we need a meaningful value here. We don't want void. We want something like write success or something. You know what I mean? That's what we want. We want a union type of write success. So that's what I think. Let's get Claude. Claude, based on what you know of our coding style, plus what you have in Claude MD, plus what you know of the Never Throw library, do a code review of index.ts. Now is let Claude identify if there's something I missed. Now, sometimes people want Claude, just give me a code review summary, right, ahead of time. Other times, I think it's interesting because I want to see what I missed. I want to understand what my blind spots are. See how its report is. Okay. Function declaration style. So it's going to change those. So again, something like Biome.js or Prettier, some of those have a fix option. So you can just kind of like put this in Husky. So as you save the file, it literally fixes it as you write it. If the AI was writing it, it would fix it as the AI wrote it too. So these, styles should be embedded, but I'm curious, what did it find explicitly? That's good. It's talking about where it found it, which is helpful. Expression versus statement. Yes, we don't want statements in our code. We're not doing imperative style. Minor issues, type narrowing. Type of is dangerous. That's true. Better typing. I agree. Destruction error, but not using it. Yeah. So unused variables, very concerning. That's good. So it's using Z union result async. So it's being positive here. I would note the same thing. So a lot of the psychology things I've read, I don't know if it's true, but if you ever are critical of someone, even if you don't perceive it as being critical and they do, if you end on a positive note, they're more likely to remember the fact that you like them, right? Even if you said all these critical things. It's literally the order. You could say the exact same thing, but in the reverse order. All they remember is that you like them, but, right? That's what they remember. It's like, oh, well, you don't like me because, well, right? It's not what he said, but the person heard that. So I think ending on good practices is a wonderful thing. And then how we actually do it. It's one thing as a tech lead to say like, here's what we should be doing, but especially for juniors, it's not really, it's perceived as like ivory tower annoyance. Like, oh, this tech lead says do all this stuff. He doesn't tell me how to do it and how to get from point A to Z. Like some tech leads think it's A to B, but like, they don't understand there's like 50 steps they take for granted to get there. So that's cool that we are doing this and we need to fix these things, but how do we get there? So see how they actually recommend the fixes. I would copy paste this into there because I don't know if you ever seen my PR reviews, but like my PR reviews that I do with a lot of people that are interested in the coding sometimes, if we're not in a hurry, is I'll write like 3 pages, right? Because they don't understand like what's wrong with the throw keyword. I'm like, here's 5 articles, here's, but I also put it in context. I don't say go read this. I say go read this for your context. Here's that applies. And I'll actually take their code and slowly refactor it to the best practice. AI can help give you those examples that you're trying to paste in there. So it helps, reduce the writing. So this is good. This is good with the, renames. That's great. No, but thanks. So enjoyed it. This is good. So that's the examples. So I dig it. Actually, yes, make those changes. Let's see if it can make all those changes, and let's see if the test still pass. So I'm gonna do the vibe code. You ready? Yes. I'm not gonna look. So I know if you can't see it, but I'm actually only showing my terminal. Like my eyes can only see the terminal Claude side. What is it saying? It's updating code or something. Okay, I'm not gonna look at the code. I'm just gonna say yes, whatever. Sounds great. This is I don't recommend this at all, but I understand why people like this. Because if they have, tests and they have types and things like that, they're just saying yes. I don't even know what it's doing at this point. I'm not reading it. I'm just saying yes. Shut up. Sounds great. Yes. I don't know what it's doing. It's really scary. This is not how I code, guys. More functional style. Okay. So the tests are still passing, but let's do a code review. So I wrote this, which is good, but what did it change? So that looks good. I didn't even realize health check was. That's awesome. That's awesome. Okay. It changed it to arrow function. Dig it. It is structured. And it got rid of the error because I wasn't using it. That's good. We'll have to do it later. That's good. Arrow function. Good. Added a space, so it's consistent. Good. Yeah, this is actually good. Okay. Final result. That's how I recommend use AI. You write the test, you understand the requirements, you iterate on the things, following a Chicago style. So you're focused on the small little functions. You build these really strong, tested well, typed well pieces, and you start combining them together later on. So we covered a lot. That was a couple hours of coding, mostly in the way I do things. I did that crazy vibe coding at the end. It actually wasn't bad after the code review that it did after the fact. Let's talk about the types. Again, the whole reason you saw is we're using it to narrow a problem space and cite problems. Sometimes the AI just doesn't get the types right. Sometimes I don't get the types right. So TypeScript can help us both, right? Both learn what the types are, but also learn how to make our code a lot more safe at runtime, whether I'm coding it or the AI or someone else. They help provide a narrowed language that I can communicate to the AI with. So I can literally tell the AI result or result async. I don't have to say result TE, right? Like it knows what I mean. And conversely, when it says result, I know what it means if it has a capital R, right? It's a great language that communicates a lot of intent with just one word. That same word of person, the AI knows, but so does our product owner, so does our business, so does our users. So that I didn't really talk much about domain-driven design or DDD, but that kind of style and types is a wonderful way to communicate, not just from the business and your coworkers and everyone else, but also the AI, the LLMs really eat that up. It helps guide the AI to ensure the code writes is correct. So it can see, I mean, you saw in the very beginning, it saw the types were wrong in the test a couple of times. It saw the stubs were okay and the test passed, but the types weren't right. And it's like, well, I guess the test passed are okay. I'm not going to fix it. But then other times it's like, hey, man, I'll fix it. And it offered to, or, I told it to and it fixed it. Again, it helps you visually see the errors. And sometimes the AI can see the errors too, but the AI can see it everywhere. So if you give it access to all those files, it's not like us humans that have to have it open. It can see it everywhere, which is really nice. And on the test, you saw that building those tests and building the increment design, it didn't break anything else. Now, again, you didn't get to see it, but once we start combining those functions together, right, in Chicago style, we can see if we broke something way over there by accident. Usually it's not because those tests are independent on pure functions or mostly pure with stubs that we compose together. And so it helps as our code base grows and the AI gets more context and may make other mistakes. We can see if we broke something or it broke something, changing those files. But more importantly, it helps design the code we wanted to use. We like those functions. They felt good to use. They were easy to test. Most of them only had one side effect. So really nice. And again, it helps us learn the problem. You saw that we took time to step back and think, right, about like, if I read from this, how would that work? And then the idea sounded great, but like, wait, how does FS actually write? Is it async? Does it have an async version? So yes, you can do FS promises instead of FS, and that way the code can be async, so it can work with future async wrappers and abstractions such as DynamoDB or downstream API. So yeah, those tests really help you think hard about these little low-level details, let you play with the functions. So again, you get to play with the little itty bits of like the cool little Legos and put them together. You don't have to do a big problem space like you do in the London style. And again, the AI does the boring part of setting it up, right? So if you don't want to do the green part, once you saw after I iterated on Claude, it does the green part. It just gets it working. I didn't have to type that like, okay, async. It's an array with an object that has a first name and a last name, and it's made up data and has a species. Like I didn't have to type all that. It's just pow, and I could do the fun refactoring. And again, that's what I like. I want to read the code, make sure the implementation is good, but also, is this working the way I think it is? I know the types say this. I don't think the types lie, but is this really how we're doing things? And again, the Chicago method ensures small batches for you. I mean, again, you can do London in small batches, right? There's nothing, I mean, TDD is TDD, whether you use London or Chicago. It's just that if you're learning this, it can be very, very overwhelming. But if you're trying to like build a little function that you know might be a brick in a larger, castle that is your application, you start with one brick. Iterate your way. After a day, you have an entire wall built. After a couple of days, a week, you have like half your app built, right? So you should feel really good about that. Chicago helps you get there. Ensures you and the AI don't break things as you add new features. You saw what happens. Like our test only broke when I was going in large batch development, or I was screwing with the types, or I wasn't sure of the types, or the AI was implementing things based on my stubs that weren't correct, right? So TypeScript's kind of keeping us all in alignment. The tests are like, all right, this works, but like, are the types actually correct? Like from a JavaScript perspective, this is good, but maybe not from a type perspective. So the test definitely can compensate for the types being off. And refactoring, I mean, you refactor the code as you learn, right? As I learned more things about it, the AI was, I was teaching the AI how to code, but I was also learning like, how do I want to design this to abstract away Dynamo or some other, system? That to me is really fun. I like abstracting things and making the APIs easy to use, but at the same time, like they do a lot, they're interchangeable. And that's what I find fun. So let the AI do the implementation details. You know what I mean? But I also love teaching. And hopefully you saw in the Claude MD updates, I would do the same thing with a junior, just a lot more conversation, less typing and going to refile. You know what I mean? So I treat them the same way. And I mean, you saw that. We refactored the context file. We had a basic one that it generated, but I iterated on it and changed it and added things to it as to help the AI learn. And as I learned how to work with the AI. And again, like I think a lot of people when they talk about tech leads and mentoring, they say like this is how, you teach them the code, basic thing. But there's so much more there. Like that individual's background. Where did they come from? Did they come from a Python background, or were they just banging on Lua, in Roblox when they were a kid? Like that background really changes the perception of how I teach them. If they're a veteran of like, let's say 7 years and they've been doing object oriented, I have to be very careful because they're a lot more likely to be set in their ways and have expectations on how code should be. And so that changes how you teach, right? And then conversely, they teach you. They change, your perception about how you teach things and what their thoughts were. And maybe I can say it differently in the future because I keep hearing people have that, opposite reaction and things like that. And that's wonderful, right? The AI can give you a little of it. You see inklings of it in Claude a little bit, but not so much in like ChatGPT. But juniors do that. It's a reciprocal relationship. And so as you're helping AI learn, you apply the same concept to juniors, and they apply the same concepts to me. And again, I mean, usually AI was teaching me types about FS and how it worked. I didn't know how it worked. I didn't want to Google it. It's just faster to ask Claude. So yeah, for Claude, it's Claude MD. You can use an init to make one for your current project. So if you've already got all this code, you write an init, it'll actually read all of the code and go, okay, this is the style. So it'll actually fill a lot of it. So you don't have to start from scratch like I did. It can already start, from a project, which is fantastic. And again, for ChatGPT, it's GitHub.instructions.md, more for Copilot. But either way, the reason that's important for the instructions MD is that Copilot allows you to use different models. So you saw I was using Claude today specifically on command line, but at work I use Copilot, and there's different models that you can select, from the dropdown. Again, when the future comes, they're going to keep investing in different AIs and different models in different ways. You saw that Claude had like, what was it, like a 30,000 line prompt just to get Claude to work. So my prompt was like maybe 100 lines on top of that. Yeah, they're going to have different models. So this same technique and the same context files would apply to those new models, and we could iterate on. Good news, you already have your MD file. You can just add additions to it as new models come out. And again, that you saw that brown M&M. It's not really for us because we're a paying customer for Claude. But sometimes you'll see like ChatGPT and Gemini and others, they just hallucinate that they're actually in a session, they're reading your config file, but they're not. It's not set up, correctly, and they think it's there, but brown M&Ms can really help, especially if you're in a lockdown, secure environment. So again, how to speak like a pirate, or put some emoji or something. It's a brown M&M to let you know that it actually read your file. It's when you say, hey, it should respond. And then after a while, you can tell if it's not speaking like a pirate. So if you want to learn more, my recommendation is first, Paul Hammond has a very similar video of mine, and he has just, a different perspective on, I think, some of the testing and XP or extreme programming models that he does. It's good to see the same style of content, but from a different person. And I really like, how Paul was one of the first I've seen to post his Claude MD instructions on the internet. Brian Finster did something similar with his. Brian, I don't think I've seen him explicitly say it. He's a great person to follow, not just for his writings and his CI/CD approach, but also because he's like, look, as long as you put the test with the AI, like, with your code check-ins, it's fine. And I've seen like developers. I met a guy. He loves AI and he's using it, but what he does is the opposite of me. He writes the code, gets the logic that he feels important. He understands how it works. He's like, all right, this is what we should be doing. AI write the tests. So like he's still working in reasonably small batches from what I can tell, but complete opposite approach of me. Not using the test first. I don't know about types. And so that's definitely another thing to be aware of. There's a lot of people out there doing Vive videos. Watch how they think of requirements and think of success, what they define as success. What I define as success is that I know how it works enough that I can communicate through types, and the test get the behavior that I expect, that I can put these things together and say, this will solve the user's problem, and this communicates it correctly. That's what I define as success. All test passing green, we've iterated towards that. Where a lot of the others, like the code works, the test pass, we've generated them, we're good. Very, very interesting dichotomy. Martin Fowler's got a couple articles I'll post too. One of them is talking about understanding legacy code base. So the thing about legacy code bases is that there's two things that you can look at from why was this done this way. The first is what we all do, and that is we explore the code. All the code's available. Some of it looks like it wasn't touched in years, but it still has been working. And then second, some of the core files that change a lot, right? And we look at all the code and we try to load it up in our head and understand content. But there's another thing that some people do well. I don't, but some people do well. You've probably saw it today from the code commits that I do. I'm just like ASDF, WIP, doing cool stuff. Sounds great. You know what I'm saying? My commits are not really descriptive. Some people are. And the AI can read those Git commits and see that history and give you a better understanding of how that legacy code came to be. And again, if you lead with the benevolent, like the decision they made at the time was the right one for the time they made it, right? It might not be good now because it's technical debt, but at the time, it was probably the right call. And so if you have that expectation, a lot of these AIs can read that commit histories and summarize not just the code as it is now, but why it came to be. Now, again, they may hallucinate, but it's better than nothing, right? And it's better than you iterating to Git history and trying to figure it out. So the reason I bring that up is because some of those GitHub histories are spanning like 6 years, right? And multiple developers. So it's a great way to summarize it. Some of the COBOL code bases are back from the 70s. And so you're talking about millions of commits, sometimes 2 source control systems. So Martin Fowler's got a good thing on that. He's also got a good article about how it's changed the way we do things. So that's a good article to check out. If you're interested in TDD, Dave Farley's got a good rundown on that. If you're looking at type-driven development, Richard Feldman's got some good examples. They're in Elm, but they apply to TypeScript as well for the most part. You got any other questions? My name is Jesse Warden, JesterXL on Twitter. I'm Jesse Warden on LinkedIn. I'm JesterXL at jessewarden.com if you want to email me. See you later.